Good morning, everyone. Welcome to the SEE meeting and especially the tutorial part of the event. We kick off this morning with a workshop on global routing security for practitioners. Routing security is a topic that is very relevant these days with all the hijacks that we're seeing and with RPKI being a key thing. So if this is a topic that is of interest of you, this is the right place for you to be in. I'd like to welcome to the stage your trainer here. He is the working group routing chair at RIPE, and he is also the expert that will be leading you through this presentation. So, Ignas, please.
Excellent. Thanks a lot. Good morning and welcome to the SE meeting, and let's start from the important things. Let's secure the internet. So where's my clicker here? Clicker is over here. So if we listen to what is happening in the media in general and also in networking-related news channels and also all other informational sources, we actually need to start panicking right now. BGP and BGP security is severely broken, has been since the inception, and the future is really dark. So we don't have any confidentiality, all of the discussion that we'll be going to have here, that will be focused to BGP and on supporting machinery. So if we're talking about BGP that has no confidentiality and that's really bad, well, we'll try to see whether that's really the case. There's no authorization of what you advertise and who receives that and how the other parties do treat that information with and how they try to modify that or interpret it. We have no verification whatsoever who advertises something to whom and whether that has any legitimacy or not. And in general, BGP is just a patch on top of a patch. Everything is broken there. We need to scrap all of this and move to something new and shiny, like a whole bunch of JSON-speaking microservices who spend more resources on just shuffling JSON from left to right and actually doing the topology calculation. Call that the new BGP and declare victory. And that's actually the goal of this discussion here, to try to look into the practical aspects of how the global routing works from a perspective of the security, to clear out those misconceptions, and to have a discussion of where all of this is heading to and what to expect. So, Isham previously introduced this as a tutorial. I would prefer to call this a workshop or a bi-directional discussion, and with this I will not stand on the stage all the time. I'll probably move closer into the group. What I would really like to have is, it's not me spreading the propaganda to you here, but having a bi-directional discussion. If you have questions, raise your hand immediately. Don't wait until the end. Well, for the logistics, we have basically two parts. We'll run for an hour and a half, then refill with coffee, and then reconvene again for an hour and a half, and then for the most important part of the day for lunch. Whenever you want to ask something, whenever you disagree, whenever you want to comment something, or simply you see that I have no idea what I'm talking about, please come to the microphone or simply raise a hand. I will have a portable microphone myself. What I would really like to have is an argument, and not only bi-directional argument. Maybe some of you have got experiences that might be different than mine and others, and sharing those experiences would definitely be of value. Therefore, please, really, don't sit silent and just look at me. Yes, of course, I'm a nice person, yes. But far more important thing is to have, at least to try to have this communication happening here. Then the target audience. This was kind of earmarked as global routing security for practitioners. And the intentions would be that you already know how to configure these things. Now, basically, you run the infrastructure. You would be interested to hear about the protocol mechanics and how it works behind. No, this is not a local chapter of IETF. We will be not going deep into the protocol details. That's not so important. The focus would be more on the design aspects of the things, why you would want or not want to design certain things in a certain way. What are the possible problems, how to try to avoid those, and overall, how do we integrate these security aspects into your overall network design? Anyone who would like to violently disagree with this agenda or those initial statements? Is there anything else that you would really like to hear from this discussion? Any show of hands? Well, if no, then let's try to define the goals of what we'll be talking here about. So if we are talking about any routing protocol, there probably are, not probably, there really are two layers into that. We have the transport, and it has its own security implications and specifics, and then we have the information which is being carried over that routing protocol and has another set of security aspects and implications. Our discussion here mostly focuses on the information security part because that's far more important. And we'll be talking about, again, a more detailed, granular part of that, focusing more on the path validation. Origin validation is a solved problem today. Yes, there are parts that need to be maintained on the level of patches or optimizations, but in general, origin validation problem has been seeing a nice deployment uptake, and I would personally consider that problem already solved. The path validation is a different story. We are starting to see the first experimental deployments. We are starting to see certain pain points with those. There's a large body of what I would call theoretical specifications in this space. Academia is quite active also, trying to help the industry. Sometimes they succeed, sometimes, and sadly, more often than not, they fail. Definitely, we are not going to talk about a configuration. This is not a configuration tutorial, or this is not a tutorial on how to use your favorite registrar's user interface for putting in the objects to sign. There are other detailed trainings for that. It's vendor neutral. We don't have any particular favorite vendor over here, and we will try to be, as much as that is practically possible, try to be decoupled from the vendor specifics. So if we look into the routing, well, basically, you have some transport mechanism that carries some messages. Nothing really fancy, nothing really specific. You need a channel which carries certain informational elements. And if we try to partition the problem space this way, we basically have two domains. The security part deals with, okay, well, that's just a pipe. We put bits in on one side and take those same bits on the other side. As long as we do that in reasonably secure and reliable way, our problem is solved. Fine, let's move forward. The informational part, yes, it relies on underlying transport infrastructure, but that's another can of worms. The fact that you can advertise something or the fact that you have received something from somebody else does not necessarily mean at all that that party was authorized to send what it sent. That party, in fact, is the one that it claims to be, and there is no assurance that you have to trust that information. The root of this problem is that you don't have another source of information to validate this for. So basically, you have to find something, some mechanism, that has to validate what you have received without any other reference. This indeed has been the case in the BGP world for a long time, and naturally that doesn't lead to anything practical. You definitely cannot do that thing. for a simple reason. The routing information that is exchanged there, it's not autonomous. It cannot be practically contained and verified via some alternative means by any single entity. This is a distributed system. You control only a small fraction of that. You probably can attest, although I wouldn't be so sure, for example, for myself, that I can really trust what I am advertising to the rest of the world all the time. So you probably can validate and attest of what your organization, basically your autonomous system or your entity under the control is advertising to the rest of the world. Validating and trusting what you have received from others is already a harder problem. Now, trying to force somebody, well, force is not the right word, persuade somebody else to trust what you have advertised them is yet another layer of complexity. So let's try to look a little bit deeper of where the insecurities lie, in fact. Again, we need to partition the problem space into two. So if we look into the transport, that deals with your infrastructure. And my claim would be that if right now you have transport problems in your routing environment, then probably you have far bigger problems with your routing infrastructure than actually perceived insecurity of the particular routing protocol. So BGP runs on a stateful transport TCP. If somebody from outside of your administrative domain can send a stray reset, and that would impact your BGP session, indeed, your network has far bigger problems than the perceived insecurity of BGP transport. To an extent, well, not to an extent, to the core of this is the problem of proper network design and operational hygiene. If you design your network in a proper way, this problem will go away by itself. Another aspect, the industry has gained a large amount of experience, deployment experience and implementation experience over the decades. And right now, the edge-facing platforms are far more resilient to all sorts of nastiness that is happening outside, well, basically on the wild network. It's not possible to overload the node by simply abusing the transport anymore. Again, you need to do proper operational hygiene for that. Not necessarily this is just ready out of the box, but this problem is solved. You don't need to be concerned about it that much. And there's plenty of options, whatever you wish, and that fit for your environment. So let's declare victory here and claim that BGP transport side is not a problem anymore. Yes, there are deficiencies. If you want to make problems for yourself, you will certainly find possibilities to do that. But outside of that, this is not an area of major concern. Now let's look into the informational side. The major difference is within the scope. If we are dealing with transport, we are dealing with, well, in most practical cases, we are dealing with the bidirectional channel and our communication, and the risk domain is strictly bounded. On the information side, we're dealing with application. So yes, BGP is just an application which distributes the information around. You cannot control where it will get distributed to, where it will float, who will try to interpret that, and you also cannot control who will advertise what to you. So this becomes an end-to-end type of problem, and you control only one end in the best case. Sometimes you are sitting in the middle and you have no major mechanisms, not even to influence, but sometimes even to observe of what is happening there. Trying to partition this into the subdomains. you need to have a mechanism for controlling and validating and claiming that something was advertised or not advertised. You need to have mechanisms for validating of what you receive to try to find the identity of who advertised that information. Try to validate whether that identity is not forged. You need to do a deeper semantical checking whether that information that was advertised and appears to be correct from a topological point of view is indeed correct from a broader semantical point of view of how the topology is defined. Well, all those leaks and hijacks which you are happily dealing every day. So that's basically the essence of the problem space. Now, this is a far more active area of work. There are fragments. One of those fragments is origin validation. That is mostly done. But the path validation, that's still an open area of questions. And looking pessimistically, realistically, we won't see much of the changes happening in that to come to the, say, practically logical conclusion in this decade. Yes, there are important steps being done, but that's still too short of the time frame. Why is so? If you briefly look into the history of BGP as a protocol from a standardization point of view, over the last decades, it certainly has got many new, interesting and practically relevant features. Can you notice anything related to security on this list? Well, me neither. For a very practical reason. Actually, two practical reasons. First, there was a problem on routing that needed to be solved, and it was solved, and that was enough. Second thing, security mechanisms typically were related to host area network or host domain of networking, and generally they were lagging at least by some interval of time. Therefore, more often than not, at the time when new functionality or new major revisions were being added to BGP, there were no sufficiently practically usable mechanisms that could be just bolted on top of the protocol. Therefore, we have what we have. It's a mix of certain patches. Right now, things have improved. Well, actually, the last major changes to BGP happened over a couple of decades ago. What we see now are extensions, but those extensions are not to the core of a protocol, and I tend to claim that everything now is fine with the transport security of BGP. If we try to partition our discussion here and prepare for the further parts, let's slice this pie into three layers. You have the protocol part, well, basically the transport and messages and how the two BGP neighbors can talk to each other, and what is important there. And then we have the infrastructure, all that supporting machinery which provides the informational elements against which we can validate the third part, the information. Well, basically that what is carried from the application or from a logical topology point of view. So with this, let me step back onto the floor again and try to get disagreements, comments, questions. Oh, somebody's disagreeing with me. Right, so fine.
Ivan Pepelnjak,
yes.
IPspace.net. I totally agree with you that transport security is a solved problem, as in we have the mechanisms to solve the problem. Some vendors didn't get the memo, and the defaults they are shipping are so insecure to be horrible. So, for example, there is a vendor that happily accepts an incoming BGP request from everywhere over the internet.
So shame them.
Well, I do. I do as much as I can. I just want to warn everyone else that just because we solve this problem, technically, doesn't mean that your implementation is secure. Absolutely. So be careful.
Yes, definitely a valid point, and thank you for disagreeing, and please disagree more with me. Right, but I will respond back. You are very right of using the particular word, vendor. Yes, that's vendor's problem. If your vendor doesn't understand, doesn't want to understand, or has excuses, well, vote with your wallet. Simple as that. Shouldn't be too much of a difficult problem to solve. And yes, we do have a sad reality of operating systems that have uptime of 20 years, and some operators are actually very happy about that. Look, my router's uptime is 20 years. There's nothing happy to be about, right? You should reload that box as soon as you can and upgrade it, or maybe scrap it. We do have mechanisms. Yes, it's a question of education. Yes, it's a question of explaining to vendors what you want. Not all of them are willing to listen. Not all of them want to invest. It all comes down to the actual engineering budget plannings, right? So you either can implement this new shiny feature, or you can implement this old boring security thing. Right? However, if you vote with your wallet for your favorite vendor, typically they get the message way faster than me trying to persuade that, well, look, we have transport protocols that you can happily use. Anyone else would like to disagree with me? Yes.
Hello, Miguel from NetNode. I don't want to disagree, but I would like to add another part of it. It's a technical stuff, this, but how do you bring in all these issues within an organization? You need people, and you need the time, and you need to organize how to make this better within the organization. So that is also a topic, I would say, despite this technical
Absolutely.
workshop.
So you see people over here, right? That's the reason why you are all here, to learn about these things and to be able to spread that around within your organization. It very well might be that your organization has different priorities, but again, that's an organizational question, right? And it's for you basically to balance the cost versus benefit ratio. If you don't fix this, well, real soon now, maybe not that soon now, the rest of the world will start isolating from you, well, for obvious reasons. So if you don't sign something, or if you don't validate something, the rest of the global routing system will just isolate you away. And that probably will be a catalyst that would help you to regain the clue really quickly. On another hand, education, and education on different levels. So talking to vendors is one thing. And I would be really curious, can I see a show of hands, anyone who would associate themselves with a vendor here in this room? Really? Anyone? Right? So that's one of the answers, right? Or at least a part of the answer. Those communities are really fragmented, right? So if you don't have vendors in the room, they probably don't hear this message. Then if you don't relay that message to them, they also don't hear that. And typically, well, vendors, they are a coin-operated machine. If there is an RFP coming in for some functionality that would result in that many orders, they'll probably consider it. If there isn't such a thing, well, they will just ignore it. That's just a natural reality of the market, basically market self-regulation. So what to do about that? Go to your vendors or invite your vendors into the meetings like this or similar type of gatherings and conferences and explain that problem to them. Personally, from my observations, I would say some of the vendors are way better than the others. Some of them do see value and understand the benefits of being present in, well, user group gatherings or specialized conferences which don't deal necessarily with the vendor marketing exclusively. We are not there yet. Certainly there's a large room of improvement, but beyond the education and beyond voting with the wallet, personally, I wouldn't see too much of other solutions of how to address this. Well, and definitely thank you for raising. Yes, this is an important problem, although not a technical problem. Right, anyone else would have any comments or questions? Fine, let's then continue further. So, a bit of the technical aspects. Yes, we have a large choice. TCP/MD5 has been there for decades. Now we finally have practical implementations of TCP authentication option. For cryptography purists, that's a big win, but for majority of the practitioners, the benefits lie elsewhere. It's actually a mechanism to rotate the keys seamlessly and without disrupting the session, which is really nice functionality. Now, you might have heard rumors about BGP over QUIC. And indeed, there is work going along those lines in certain standardization environments. However, an important aspect to note that even if QUIC is considered or positioned as being a secure transport, that's not the goal of using QUIC in a BGP context to provide the transport layer security. The reasons are a little bit outside of the scope of our discussion. That's mostly for separating the address families and having logical channels. One of the inherent problems with BGP is that if you have a failure of any kind, that disrupts the whole session, not the address family or some other subcomponent of BGP that is being signaled over there. So that's basically an attempt to try to address the partitioning of the risks far more than trying to do something related to the transport security. Now for the informational part, and here we're starting to open the can of worms. So you have a connectivity graph, and you receive something over that, and you advertise something over that. What you imagine that graph is and how it looks like in the reality might be a little bit different, and often it is. The complexity also is amplified that this is a global connectivity graph. Fine, you might have a limited domain within your organization control, and there you can probably address this problem and, well, basically do whatever you want. If you are talking about the global routing infrastructure, no, it's even theoretically infeasible to try to define one single entity that would be used as a source of truth for trying to validate everything else. And it's not even a technical problem, it's an administrative problem. An important aspect is the cost. Yes, there are solutions which are theoretically / academically perfectly correct, and they work on paper. However, in practice, they work a little bit, slowly, so to say. If convergence of a global routing table takes multiple hours, you probably wouldn't be too happy about such type of a solution. So yes, validating and in general dealing with anything that involves cryptography has its cost. You shouldn't have an opinion that cryptography is evil. No, it's expensive, yes, that's correct. Is that prohibitively expensive? No, and the answer for you that is all the HTTPS infrastructure, well, basically TLS world. That is working perfectly fine, and I would argue that a far larger scales than the amount of information that would be carried over the BGP. And sadly, this is not a substitute, or looking on the other way, this also cannot be compensated by the proper operational hygiene. Even if you do everything perfectly on your domain, you cannot control and influence what is happening else. And that is one of the main reasons why we see all sorts of these attacks happening around. Well, for leaks, I would claim that you are mostly responsible, but for hijacks and all sorts of other invalid announcements, well, blame your neighbors. So we are coming to two important parts of the information security part, the origin and path validation. So let's look a little bit deeper of what that magic infrastructure, which does these things, is required and functions. So first, to clear one misconception. Many times I've heard the saying that, oh, RPKI, so yes, simple thing, the routing PKI, so basically we put the public key infrastructure into routing and that's it. No, it's not routing PKI, it's resource PKI. Routing is just one user of that infrastructure. So basically, think of it as a distributed database that stores all sorts of various objects, resources. Those resources, for the context of networking, they are prefixes, ASs, router keys, and well, things related to the internal operation of that infrastructure. And this forms a hierarchy. Another common misconception is that, yes, there are 5 global routes in the global routing security, and that has been for ages, and this is a given. No, that's not true. If you wish, you can have your own trust route for experimentation for your own infrastructure, and there are way more than 5 of those globally. We can argue for long whether that is needed. However, my intention here is to clear some misconceptions about that. So we don't have a fixed amount of trust routes in that hierarchy. All this RPKI infrastructure is not directly usable by your BGP-speaking routers. There is no such thing as an RPKI session to your router. You have a certain level of call it middleware components that offload and isolate the router side from the complexities and computational complexities and the cost of a cryptographical infrastructure, and at the same time provide the scalability. You have far more router entities in the global infrastructure than the information sources of truth or the RPKI repositories with which you synchronize. Path validation and origin validation, those are just applications of the RPKI. They use the same infrastructure, same machinery. They use slightly different objects. Naturally, the information that is relevant for the operation is different. But apart from that, this is the same infrastructure. If you have deployed origin validation, the incremental costs for deploying path validation are not that large, depending on which flavor of path validation are you looking into. You don't need to do much of your infrastructure and machinery. So using all of that, quite a simple thing. The main reasons of why you have partitioning like this is to isolate the amount of information that needs to be propagated. You have layers of caching. Because another concern is the overall network convergence. So now if we are talking about a standalone BGP only, it converges in certain speed. Tens of seconds generally is a good number, good ballpark number for trying to quantify how it converges on a global scale. However, when we add in the validation part, first thing, that information which is needed for validating needs to be distributed, so there is one level of convergence. The other aspect is that the router itself needs to react to the changes of that information. That adds to the overall convergence speed. How much does that add? Very much depends on the network design, and that's less of a technological point and more of the trade-off between the design, between the resource consumption, and between the reaction to certain changes in the network. And this is something that needs to be taken individually in your environment. What the router speaks to is called RPKI to router or RTR protocol, a simple, mostly one-way, although with time extended to a bidirectional communication mechanism, which provides the end results of the RPKI artifacts translated and simplified for the actual end router to use. Historically, routers have been underpowered, severely underpowered, and doing cryptography for validating all the hierarchical chains, that's certainly not the right venue for doing that. Validator, the middleman, the component, the middle component, offloads all of that, caches this information, and sends out to the routers. That's a natural engineering decision, a good thing to do, and well, basically, it addresses a practical problem in a practical way. So, origin validation. All you are familiar with that. Well, just for my own curiosity, anyone definitely not familiar with what origin validation is and how that works? I'm really happy to see no hands, definitely. So, the overall idea is we have an autonomous system and we claim that this autonomous system is authorized to advertise this particular prefix. Keep in mind, we don't say a word of where topologically in a connectivity graph this AS or this prefix lives. And that's completely not a problem of origin validation. That's path validation. The end result of this process is one of the three states. It is this correct AS that advertises this correct prefix. No, something is wrong, or we simply have no data to tell that. Now, how from the router perspective to use this information? By the policy. There's no some magic hidden process. This boils down to policy. It might be implied, which is not necessarily seen in a configuration that you see. More often, this can be traced back to certain configuration primitives. And the actual decision taken what to do with this prefix, it boils down to the configuration. Broadly deployed, everyone is doing that. Well, at least everyone should be doing that. It certainly helps. Yet there are problems. That's not enough. So now if we look at the problem space, even if you have a validation that this particular AS can originate this particular prefix, nothing would prevent some other entity to pretend to be that particular AS and advertise that prefix from another point topologically in the network. An origin validation was not designed to try to address this problem for multiple reasons, not the last one being that this is indeed a complex problem to do. So, the overall problem space is path validation. We need to do something to try to decide whether the path which this update claims to have traversed for this particular prefix actually is the one that it is supposed to be, it is correct, and well, it is verifiable against something. Whether that something is cryptographically provable or not, those are two different schools of thought, and we have two different sets of technology approaches. Now we are coming into a territory that is not that much practicalized and deployed. ASPA, or Autonomous System Path Attestation, AS Path Attestation, is something that is gaining initial deployments. And the overall idea is very simple. We have a statement that this particular AS has a relationship with this other particular AS. Right? And if we apply this recursively to the whole path, we actually can validate that this path that we have received actually meets the sanity criteria. And that it actually corresponds to what that path should have been. However, important aspect to note, the path validation in the context of ASPA doesn't say anything about the origin validation. So, first thing, we are dealing only on the AS path or on the AS number level, and we are not dealing with prefixes. And it well might be that while the path is correct from the ASPA perspective, that advertisement is incorrect from the origin validation perspective. Yes, this is normal, this is expected. The outcome of that, you need both of these mechanisms if you want to have practically usable and practically deployable BGP security mechanism. This comes at a rather minimal cost to the RPKI infrastructure. You need to add a few more objects. And also comes, and it mandatorily requires some minor changes to BGP. It adds in the concept of the role. So you define the role of a speaker to be a peer, a client, and a route server, something else. And there are relationship pairs that only those pairs are allowed to establish an adjacency, and only between the certain pairs you are allowed to advertise something. You might think that, oh, well, so this is just another community. No, it's not a community. It's a separate attribute. The reason for doing that, it was believed at the time that modifying the community is too simple to try to circumvent this. Therefore, it's another path attribute. However, well, there are implementations that would allow you to modify that. Not many, but there are. There's certainly nothing preventing for malicious actor to try and modify this in transit. There's no cryptography involved in this. Well, it's just an attribute that carries an identifier. This comes at a rather minimal cost of changes required to BGP. And that's one of the reasons why we see initial deployments of ASPA in an experimentation mode. It's simple to try. If you already have your PKI infrastructure working, it's not too difficult to try to extend that. Another school of thought is let's put hardcore cryptography into BGP and validate everything and everywhere. And that's the right solution to do. What it allows you is to bind the prefix with the actual AS path. And whereas ASPA is something that looks forward, if the announcement is advertised, then you can look in whether it was advertised into the pair that is authorized between the ASs. BGP-SEC looks backwards. If you receive an announcement, you can trace back and actually validate that the AS path that it is claimed to be is actually correct, at the prefix that is claimed to be advertised is actually that prefix that you actually have received. The outcome of ASPA is similar to the one of origin validation. If you don't have enough data to make the decision, the only thing that you can decide is that, well, sorry, not enough data, it's unknown. And you fall back to treating that the same as you treat something that you cannot validate. BGP-SEC is binary. It's either valid from a cryptography point of view, and we'll talk later about the actual mechanics of how that is done, or it is not valid. There's no middle ground. Security conscious engineers are very happy about that. Practical practitioners, security conscious engineers, are not too happy about the convergence and overall cost of BGP-SEC. That is expensive. Well, anything that is related to cryptography has its cost. Is it bad? No, that's not bad. Is that cost justifiable? There are problems with BGP-SEC the way how it is specified. It's academically usable right now. It's not practically usable right now, but that's a problem to be sorted out not for this room and for this organization here. That work is slowly but ongoing, and there are some promising results. However, if we are looking from a practical point of view, BGP-SEC is present only in some very limited experimental setups. On the other hand, nobody would expect to see BGP-SEC being deployed globally end-to-end, and we will talk about that probably in the second part of this discussion of why, when we move into the details. So, finally, cryptography moves into the BGP layer. Whereas you didn't have anything like that on the BGP side for origin validation and for ASPA, here you have full-scale ability to validate the things. So this is kind of a summary of our initial first section, and once again, I want to move closer to the center of the room. I'm looking at the gentleman over there. He certainly wants to disagree with me. Okay.
Realistically, Ivan Pepelnjak, ivspace.net. Realistically speaking, if we combine the origin validation with the AS path attestation,
ASPA.
Is there any real need for BGP-SEC apart from real security-conscious environments like maybe banks exchanging data with each other? So how realistic is it to use, or how do we need to use BGP-SEC on the generic, usually untrusted internet level?
Okay, so I will probably tweak your question or partition it into two parts. You mentioned BGP-SEC. It's not the only alternative, right? So let's first look into the part whether you need something more beyond ASPA. One of the cases is where you have origin validation and ASPA, and well, everything is fine. But how do you differentiate when one of those two, suppose you have a triangle, right? Two upstreams, right? And or you are advertising to two upstreams, it works symmetrically. So your origin is correct, and basically a pair of ASPA validations are correct. How can you ensure that this prefix was advertised by correct of the two? You cannot, because ASPA doesn't deal with prefixes. No, origin validation says, well, yeah, yes, it's fine. Everything is fine. So you need a mechanism which binds the two. So either you go into more prefix level granularity with ASPA, which you don't want to do. Please don't break ASPA. We need to deploy it because it solves majority of our practical problems. How realistic is this? I think you certainly would agree that this is not an imaginary scenario. Think of an exchange, right? Or think of even of a private pairing which has multiple pairs on the same topological level, and a hosting environment, for example, right? So you might want to take a mic. No, just take a microphone.
So while I totally agree with you, what you're saying is I'm running two tests and they're orthogonal to each other. One is this prefix allowed to be advertised by this autonomous system, and the other one is the AS path from this autonomous system that supposedly advertised this prefix to me, yes, a reasonable one. And of course, you can get disagreements and all that, but yet again, how realistic is that? So if I'm doing full route origin validation and drop the invalids, and let's ignore the unknowns for the moment, and I'm doing full ASPA validation, and yet again, drop all the invalids, so I have a valid answer on both dimensions.
But not at the same time, not necessarily at the same time, and that's a key.
No, I have, for the same entry in my BGP table, valids on both dimensions.
Correct. But that doesn't mean that it's basically a logical OR operation. It doesn't necessarily mean that it is logical AND operation for all the topologies. The important part for all the topologies.
Yeah, but we both agree, right, that the only thing that makes sense long term is to have a logical AND, not a logical OR.
I'm not too certain whether it's strict logical AND in all the cases. There are corner cases which, for example, are very important for somebody, but globally they are on a noise level,
yeah,
right? And to try to complicate the solution for covering these corner cases, well, we get BGP-SEC on steroids.
Well, that's
and we don't want to do that.
What the IETF job is, right? To solve all the corner cases.
If we look from a practical point of view, ASPA covers majority of practical cases. You certainly have topologies, and some of the, well, in some narrow environments, those topologies are very broadly deployed, right? But it's not the other way around.
So are we in agreement that origin validation and ASPA is good enough for like 99% of the global internet? And
Probably
everyone...
less than 99, but it's above 80.
Yeah.
Definitely above 80.
And whoever wants to use BGP-SEC to cover their corner cases should be free to use BGP-SEC to cover the corner cases.
Or something better than BGP-SEC.
Yeah, that's a different story.
Okay.
Yeah. Thank you.
Right.
Yeah. Yeah, Tim Rijels, right in CC. I'm going to talk about this stuff a bit tomorrow as well, actually. So I wanted to say, yeah, about ASPA. I think one of the design goals of ASPA was actually about root leaks.
Yes.
So that might be important to mention. So, but BGP-SEC, if it is deployed, would allow you to say this is exactly what happened on the control plane. ASPA would allow you to decide, and this is actually something that we can expect to happen. So they're orthogonal technologies in that sense. But I agree, like what ASPA will do with origin validation is, of course, path spoofing is trivial. So origin validation alone protects against typos or where you have good knowledge of the topology. ASPA will make path spoofing more difficult, at least. So in that sense, I think that goes to the 80 or above 80% where it will actually solve problems. Beyond that, yeah, then maybe BGP-SEC is yet an additional step. But the important takeaway, I think, is that it is by design trying to do a different thing.
Precisely. Right. And the best thing about this is that ASPA is not intended to be a solution for all problems. Right, and that's not the goal. Well, BGP-SEC to an extent was an attempt, right? I would say a very successful attempt. It was a little bit ahead of its time, and it also has certain, well, certain reality problems. But those reality problems, we will try to see that probably in the second part of this discussion. Those reality problems can be fixed, right? Now, whether that's 80% or 99%, no, definitely not 99%. I think you certainly can come to a very specific topology which would be relevant for a very specific environment that ASPA plus origin validation would fail to detect something. And that's not the intention, that it would be a universal tool. Whether it would allow life harder for 80% of commoditized attack types, or those leaks which happen, well, basically because of rather commodity reasons, yes, definitely. Probably more than 80%. You know, this is guessing. We still have too little of a practical deployment of that, practical deployment experience. That is still in the very early stages. We are probably, well, like 5-8 years behind of the level of acceptance of origin validation. Give it a few years, we'll see better data, and we'll see how that progresses, right? So are you now in agreement? Right, anyone else? Yes. Whichever you prefer.
Yeah. So I'm Zubair, a PhD student at Max Planck Institute. About ROVA, you talked that it's possible that currently some malicious AES may use the same AES number and announce the prefix, which is still valid in terms of ROVA, but it's like a malicious use.
Yes.
I was thinking, is it possible for the ASPA as well that someone claim that it has a path to that target? Let's say,
of course,
A says that my provider is B, but then some malicious AES, C claims that I have a path.
You have a
B
pair.
to A.
You have a pair, not a path, but a pair. ASPA operates in pairs. So basically, it's a verification that this particular AES has a relationship with that particular AES.
List of providers, basically. So every AES put the provider. This is what I see in the RPKI validation, at least.
Well, it's probably a terminology question, but ASPA operates in pairs. So you take the whole AES path, split it into two element segments, and validate each of those pairs, right? Yeah. ASPA as a concept validates whether there is the relationship between those pairs, not the whole path. That's the domain of BGP-SEC. So yes, of course, you can craft an AS path that will look like something that is valid,
Okay.
and some elements of that will be validated. Most probably not all, because you most probably will not have ability to influence the other remaining elements. Yeah. So basically, what you can forge, you can create, and you will advertise that. It does not necessarily mean that all the subsequent elements that get added will actually have, well, basically the first element that gets added will have the correct pairwise matching.
Okay. Okay. Fair enough.
And this is by design. This is not a design error. Right. Any other comments and discussions? Right. How we are doing on time? So still coffee? No, still not coffee time. Right. Let's continue then. So ASPA, we actually ran ahead a little bit of this. So I think I have covered, at least briefly, all of the things. So the outcome, again, the outcome is coming into the routing policy, and it is for you to decide how you treat that. Many of the vendors will provide you with some details. Sometimes you won't even see those details, but it comes down to the policy constructs that allow you to take the decision. And the overall operational process is you receive an announcement. It goes through the policy, and policy takes basically policy modifies external or internal attributes related to that announcement, depending on all these validation outcomes. So let's talk briefly about BGP-SEC. Anyone running BGP-SEC here? Tim? Right, no. Probably nobody is running that in production. There are only a few experimental deployments, well, myself including, but we still have a long way to go. So, what it is? The overall idea is very simple. You have an AS path, and that's the only critical element that needs to be protected. All other attributes, technically all other attributes can be modified by any other transit node, and they are not supposed to be end-to-end consistent. AS path must be. Therefore, if some transit entity does something to an AS path, that gets propagated. The idea is very simple. Sign the AS path, sign the element of an AS path. In that signature, include the prefix, include the actual AS path element, and include to whom you are advertising that. And basically, this gets a triplet that uniquely identifies what we are advertising and to whom. And each transit node does exactly the same. Then, when one receives the BGP-SEC update, they can repeat this process in reverse and can have a validation of the signature. And this is a cryptographical proof that actually this prefix has traversed this particular AS path. The actual protocol mechanics is quite a bit complicated, and we'll go into that. But from a concept perspective, it's really simple. The only problem is quite expensive to do. BGP-SEC is not a new thing. It has been around for around a decade, and the ideas started floating around probably around, well, 2000 timeframe. Yet, from the practical deployment perspective, we are nowhere yet. From a vendor perspective, that's not supported because they don't see a market traction for that. There is no market traction for that because it just does not work conceptually, and we get something like a closed circle. However, there are movements mostly from the perspective that the industry is trying to understand that the initial deployment model for BGP-SEC was not right. BGP-SEC was meant to do a global world domination, same as ATM. And you know the story, the success story of ATM. So it was meant to be end-to-end, and all the cryptographical verification has basically plausibility only in the end-to-end domain. However, running cryptographically strong validation end-to-end appears not to be needed in the global connectivity system. Where we need really strong attestation, those are limited domains. Exchanges, first thing, which probably for the majority of the cases we are talking about the 2-hop AS paths. Certain private peerings, where we need to validate that these particular high-value prefixes are advertised really by those from where they should be advertised, and not by some other adversary, and by the fragments of the global connectivity graph. Not end-to-end. And if practical BGP-SEC deployments will come, they will come from these domains. And that's actually what we are starting to see. So, why BGP-SEC? Why do we need that? It's not enough to have the binding between prefix and the origin. It's not enough to have a binding between the pairwise elements of AS path. There's also a subtle difference in interpretation. With BGP-SEC, we actually prove or validate, or we have non-repudiatable proof that this particular prefix has traversed the path. With ASPA, it's a little bit different. It's more of the to whom this can be advertised, and whether advertised, whether should it be treated or not. There's no cryptographical proof. There's nothing related to actual strong cryptography for the pair role signaling. If some transit node or malicious pair modifies that particular attribute, the logic of ASPA resolving might change, and that's actually by design. So if we are looking about a routing security system that deals both with hijacks, leaks, intended and unintended, we are coming to a conclusion that all three of these elements are required. Maybe with slightly different ratios in the whole sum, but this comes to be something similar to a triangle. You have origin validation, you have ASPA, and you have BGP-SEC. And the outcome of all the three is combined, again, via control of the policy, and then you have practically strong attestation that what you have actually received is actually what it is supposed to be. So, BGP, the perception of BGP-SEC. Now I'm looking into the audience and I'm looking into the time and also trying to sense the group. Do you want to get into the hardcore details right now? Do you want to raise any questions, or do you want to have a coffee break for this? The stage is yours. The floor is yours. Please raise, whatever you wish. I certainly can discuss this probably for 2 days, but I don't want to basically torture you with all of those details. What I would really like to see is a discussion between you. Well, you are practitioners, you are running the things. Do you agree or do you disagree with this? Do you have any interesting or painful experiences to share? Do you believe that this makes sense, or this completely doesn't make any sense and we should go back to typing commands into our routers as we did 25 years ago and everything worked fine? Right? The floor is for discussion. Anyone would like to? Yes, I fully understand that you all like me to spread the propaganda about how bright the future will be with the global routing security. But this is a gathering. This is a meeting of exchanging the information and experience. Anyone would like to say something? No? Okay. Tim would want, definitely.
Well, I just want, so Tim was right and sincere. I just wanted to say it from the side of producing the certificates needed for BGP-SEC, the problem isn't that difficult. So I think the problems are really with how this is used in BGP itself and how this is supported by vendors and experience that we build up there.
Yes, we already, well, you have already built the RPKI infrastructure, right? That's just another object there. So that is one of the reasons why origin validation took a while, because we needed to build the infrastructure. That's the reason why ASPA is taking much faster, because we already have the infrastructure. ASPA is just another object too, right? Plus some other modifications to RTR and then bits and pieces. BGP-SEC, from a perspective of RPKI infrastructure, is just another, well, just another object. Well, a couple of another objects, right? From a perspective of RTR, it's just another message, and then some fields done a little bit differently. But from the whole BGP and the implementation point of view, that's a completely different story. Yes?
With the risk of being between everyone else and the coffee break.
You have like 15 minutes. So.
Okay, here we go. We all agree, I guess, that the problem of origin validation is that it validates the origin and someone can shorten the AS path and therefore hijack the prefix. Mm-hmm. With ASPA, we get the check of whether that shortened prefix is potentially valid.
Potentially, yes.
Yes. And with BGP-SEC, we get the attestation that the update really traversed the AS path that is in there. So what's stopping someone that wants to hijack the prefix to connect to two places that are wide apart on the global internet? Take the prefix, which they can attest to getting, transport the prefix to the other end and announce it over there, which with shorter prefix, and then hijacks the prefix that way. Because it will be totally attested with BGP-SEC because the prefix traversed that path, and the only thing that can stop that is someone saying, gee, this is coming from my customer, not my peer, so maybe I shouldn't trust my customer. But that's not part of BGP-SEC. I don't know whether that's part of ASPA. So we would still need the routing database to check whether the things that are advertised by peers or customers are actually sane.
So what you describe would work if you do tunneling. That's,
absolutely.
Yeah.
Yeah.
If you don't do tunneling, you basically break.
Hey, I'm a villain.
So, you know, then if we follow this path, we can easily come to a logical conclusion that I can get control of the router. Well, once I get the control of the router, I can do absolutely whatever I want. And no protocol, no machinery would stop me and basically prevent from doing that. I think we're not talking about that. BGP-SEC requires end-to-end BGP-SEC. If that continuity is broken, then it's broken, and that's it. Basically, the segment is terminated. So unless you do tunneling, you cannot do that.
Yeah, so Tim Rijsels again. I think one of the challenges for BGP-SEC is to deal with partial deployment. Because it's either valid or it's not valid, but you know, the world is not going to use, not all of the world will use BGP-SEC in one go.
But again,
so you
that's
have
policy.
per sessions, right? But essentially there's this option for a downgrade attack. So you have BGP-SEC sessions, you have non-BGP-SEC sessions. So how do I know that something that appears on a non-BGP-SEC session is wrong? I think that's a hard problem to solve, because if I just see this is a BGP-SEC invalid, then yeah, and drop that, yeah, that's only one part of the story. Okay, if I'm going to try to lie, then I'm just not going to opt into using BGP-SEC. So how do you then know that I should have used BGP-SEC?
All right, so I would comment on one side. The fact that something invalid does not necessarily mean that it cannot be used. That's, again, that's a policy decision. And if we are talking about a partial deployment, that probably it will be a very simple thing as we had with dropping or not dropping invalids and dropping or not dropping unknowns. Right? It's incremental. There isn't such a thing that if a signature fails, basically it must be dropped. No, it must not be dropped. It's an indicator into the policy. Now, about the downgrade and end-to-end things. The current thinking in the industry appears to be that BGP-SEC is not going to be end-to-end. It will be limited to 2 hop in general case and 1 hop in a more specific case type of deployments. Basically, where you need to authenticate one central entity, being a route server, or authenticating a high-value peer for private peerings. And here, most probably you are more concerned about having this ability to strictly validate something than to be concerned about some downgrades, because you would simply not allow the downgrade there. You either do BGP-SEC or I don't pair with you.
Yes, if you know that you cannot. Yes, I guess that's what I'm trying to say. If you know that, if you can recognize a downgrade and know that you cannot allow it, then things get easier. But it's harder to know that at the global scale.
Most probably we're not talking about the global scale for any practical purposes. BGP-SEC has many of its roots and origins in academic research. There's nothing wrong with academic research. That is needed and required. But it also needs to have a practical reality check. Again, if full convergence, if a convergence of full routing table takes more than 1 hour, and you cannot assume that over that 1 hour you won't get any incremental changes, that basically means that the convergence process will never stop. You are probably not too happy with such a solution. However, that's not the case. Again, we are coming to a certain closed loop that the sad situation with which we are with BGP-SEC is a result that it didn't get enough of the early field trials at the time when it was being designed 15 years ago. When it was finally polished and published, somebody tried to deploy that and was a little bit surprised by the results. And those results then later came back into the standardization organization, and that process now iterates. We are nowhere near yet. That will take probably a few years until we see first larger scale practical experimental deployments of BGP-SEC, although infrastructure is ready. That's not too difficult of a problem. But for this to be practically deployable, you need to have the industry buy in. That means the vendors need to implement that, and you need to have something that is able to be deployed. This typically is a long cycle and definitely would take at least a few years. Right, so with this, I do see some people moving back and forth. Let's do a coffee break / discussion. Well, if you insist, we can have hallway discussions, although I would really prefer to have that here in the room. And then half an hour later, let's convene back and continue our deep dive into the BGP-SEC operations. Coffee time. All right, let's continue. So the second part, and this one will be a little bit deeper look into the BGP-SEC. Now, colleagues, a question actually for all of you in the audience. During the break, I got some feedback that what I have been talking here about previously is way above the level of comprehension and perception. It's too deep, too complex, and in general, you are talking about some science fiction. Is this really the case? Do you find this too deep, too complex? Any feedback? Anyone? Well, that means that this is just the right stuff, and I will continue exactly like that, or even go a little bit deeper. Well, let's go. So BGP-SEC. If we look into the feedback in the industry about the BGP-SEC, we have a whole selection of statements. So let's take a look into that. Well, it's claimed that BGP-SEC just doesn't exist, so what's the point of talking in a practitioners' conference about the things which do exist only in academic theory? It just does not work because reasons. It's too slow for any practical purposes. It has a large cost of deployment. You need to replace all of your hardware kit because this is hardcore cryptography and it just cannot be done on 20-year-old existing platforms. Now everyone is talking about the origin validation, so does that mean that origin validation is not enough for this problem to be resolved? It cannot scale because it changes the whole resource conservation paradigm of BGP. It also shows the things to external entities which you would probably do not want to show. And it's some academic experiment. The real security problems lie elsewhere, or probably there's no security at all, just because BGP is inherently a secure routing protocol. And dealing with anything that relates to public key infrastructure means dealing with keys, and dealing with keys is complex. So let's take a look into that. BGP-SEC itself is a rather simple idea. You cryptographically verify the AS path. The actual information element that is carried along with an update, and that indicates where it has passed. So this is a proof that this particular announcement has traversed over that particular router. What is important here, not necessarily an AS, but a router that signed the update. This has meaning for external BGP sessions because it works on modification on AS path. Inside of an AS, you don't modify your AS path, therefore it makes, well, practically it's no operation to try to do the signature. There are no changes. The signed previous segments are just propagated without any modification. The security of the overall path is achieved by forward signing. You take what you receive, calculate the hash out of that, those are technological details, and also include into that the identifier of AS number to whom you advertise that. This means that if you advertise the same prefix to two different upstreams, you will generate two different updates and you will have two different signatures. And that is by design. This allows you to actually validate that this was announced over this path or over that particular path. Another big change in BGP-SEC operation is that it operates per prefix. So you lose an ability to do what is called attribute aggregation or attribute packing, where you have multiple prefixes with the same attributes. You cannot do this because in BGP-SEC signature, prefix, the individual prefix with its fixed specific length is part of the hash, which is being used for signature. Beyond that, this is just another public key crypto system. And for that, this requires key management. Basically, the elements, the routers, which sign the elements of AS path need to have their own private keys. How to distribute those private keys is outside of the scope of BGP-SEC, but this is a practical problem. If you don't have the key, you cannot sign. If you leak, basically, if the key is compromised, the signature can be forged. It's exactly the same problem as you would deal with your host keys, you would need with your API secrets and similar cryptographical, basically private key material. There's nothing different from the perspective of secret management. Yet there is a perception in networking community that distributing private keys to routers, it's some form of art and science and is complex. No, it's not. If you have infrastructure in place to distribute individual configuration to your router nodes, that's no different. You just use another information element for that. Another widespread misconception. BGP-SEC doesn't encrypt anything at all. What you can see on the wire in regular BGP, you can see exactly that same minus changes in the attributes on the wire for BGP-SEC. It deals with authentication. It doesn't deal with encryption. Nothing is encrypted. That's by design. It's not going to be. If we are talking about a global routing system, it deals with publicly available information already. There is no point in trying to encrypt what you advertise to others, even if you do that via some transit third party. This could be understandable if you are dealing with some limited domain deployment or some private address family or something like that. We are talking about a global IPv6 and global IPv4. Reachability. Information about all of the prefixes and who originates them is available in public. Therefore, it just makes no sense to try to somehow encrypt that information, well, beyond doing an academic experiment and using yet more resources. How the protocol operates. It introduces a new attribute. Basically, the AS path is changed. So instead of carrying just the sequence of AS path numbers encoded as integers, this carries a larger structure, which includes that same AS number. It also includes the number of hops that might be prepended. So this is one of the solutions. If somebody wants to prepend 255 times theirs or their neighbor's AS, now you have a far more efficient mechanism for that. So that might be one of the motivating reasons to move to BGP-SEC. As a consequence out of this, BGP solves the route server hidden route server hop problem, which is in fact was a mistake of the route server architecture design. It's understandable why it was done, just the way how that was done was not right. So now, even if you peer via the route server, you don't see the actual ASN of the route server in the AS path, which was reflected via the route server. If you are looking from a troubleshooting point of view and you peer with multiple exchanges and you have not the most trivial topology, this is a pain. BGP-SEC solves this in a really nice and creative way. Inside of the encoding, you have a field that is called a hop count, and for the route server use case, that hop count is 0. You still have a signature, you still indicate which ASN was used for generating that signature, but that AS hop does not exist in the resulting AS path, the derived AS path, which is later used in a policy. This certainly helps from the practical maintainability point of view. BGP-SEC, yes, there is a widespread notion that BGP-SEC is not partially deployable, it's all or nothing. Not really so. If you enable the functionality, you don't have to enable it for all of the prefixes. You might protect only the important prefixes or whatever ones you see initially. It does not mandate that it has to be enabled for all. However, for one particular prefix, you either have the unsecured AS path or secured AS path. You cannot have a mix. Again, this is by design. BGP-SEC itself is non-symmetrical. You can only sign and receive unsigned updates, and that is going to be one of the first initial deployment models, where your upstream verifies the signature for you and sends back to you already the removed AS path without the signatures, while you sign everything yourself. The way why this works is that for validation, you don't need to have access to your private key. Anyone with the access to the RPKI infrastructure can get the corresponding public key and validate the signature. BGP-SEC also mandates some nice extensions to BGP, which are good to have regardless of whether you are using or not. Initially, BGP-SEC was defined to use the RSA crypto system. And RSA signatures are large, just because the key length itself is large. One of the practical problems, initially BGP had a 4 kilobyte message size limit. And when your signature is on the order of 400 or 800 bytes, you are getting quite close to the limit of what you can put into the one message. That was a motivation for having extended BGP messages, where you can have up to 64 kilobytes. And as we know, 64 kilobytes should be enough for everyone. Therefore, now it's mandatory to have extended messages with BGP-SEC, but that was kind of a catalyst to allow this and basically finalize the extended messages to be used for all of address families. It also requires AS4, which is also a good thing, basically a 4-byte AS. All the fields are encoded with 4-byte notation, and therefore it's not backwards compatible with AS2. Long time overdue, in my personal opinion. We are way beyond the point where we still need to care about the AS2 compatibility. All the platforms have moved along. This is no longer a problem. From a cryptographical point of view, again, there is a misconception that this is something very complex. The complexity lies in our PKI infrastructure, and we can just use the fruits of that hard work that has already been done for origin validation and now is being reused for path validation for ASPA. BGP-SEC only requires a few of the additional objects inside. And the main difference is that it would require certain objects per router. Of course, in BGP-SEC, each individual router signs the updates. Therefore, for the rest of the world to be able to validate that, there needs to be records of the public key, which corresponds to the routers that are signing. Now, this is a design question, how granular your key needs to be. We will briefly cover that a little bit later. Then from overall infrastructure point of view, it's just exactly the same RTR session with some extensions that feeds in the public key identifiers of what you need to validate against. The overall signature mechanism works on assigning the triplet. That's the prefix that is being advertised. That's the actual AS path. Initially from the originating node, then all intermediate transit nodes, and then including the target ASN to whom we are advertising this. The way how elliptic curve, the specific instance of the elliptic curve cryptography which is being used for BGP-SEC works, it requires randomness source for each signature. Therefore, if you sign the same update with the same AS path to advertise to the same neighbor AS, once again, the signature numerically will be very different, and that's by design. Statistically, it has to flip 50% of bits from a cryptographical strength perspective. And this might look, well, unexpected and may cause some capacity issues for your monitoring system. So if you are used to collecting what you advertise and receive via BMP or via some other mechanism, and you deduplicate what you store, you would not be able to do that with BGP-SEC in this particular instance. Each and every announcement will be different, yet that it will sign exactly the same information being advertised. Again, this is by design. That's just the way how Weierstrass elliptic curves work. They require the source of randomness for each signature. If you don't do that, it's really trivial to recover private key by just having two different signed messages. Therefore, one of the practical limitations for BGP-SEC deployment is that your platform needs to have a performance source of randomness. How complex can that be? This is just a random number generator, right? Let's do some calculations. Full routing table today is what? 940,000 prefixes. Suppose 1 million for simplicity. You have 100 pairs. That's 100 million updates. So in order to sign all of that, you have to have 100 million elements of 256-bit or better randomness source. That's not a trivial amount of randomness to generate, and surprisingly, this might show up as a limiting factor in the performance. Not just the raw processing power required for calculating the signatures, but generating quality random data is computationally not an easy task. The signatures are hierarchical. What is received from the advertisements from your incoming neighbors is verified. If everything matches fine, when you advertise that further, you add another segment. And basically, it works in the same way as an AS path, where advertising router adds an ASN over which it has traversed. Here, instead of just only the ASN number, you add two other elements: the signature itself and the identifier of the public key of the router which signed it. This is for the rest of the world to be able to validate that particular signature. If we are looking from a receive router's perspective, so what is needed to verify and ensure that AS path is valid, you need to recursively verify each and every segment. This means that the cost of computational power grows as the path grows. And the concern here is the closer you are to the edge of the global connectivity graph, the longer as paths are, just because you are further away from the core. And that means that validating at the edges computationally will cost more than validating closer to the core. And it might be that lower performance platforms exactly are deployed closer to the very leaves of the connectivity graph. However, cryptography is computationally expensive. Properly implemented cryptography is reasonably computationally expensive. Overall, this comes down to the system design. If you implement it in a textbook way, don't be surprised that it will just not work. If you implement this in a professional and credible way, taking into account the practices in software and hardware engineering and not looking only into a network engineering aspects, that will work at a similar cost that is required for other heavy cryptography systems to operate. Probably we don't care too much about the added load of, say, HTTPS or some hierarchical crypto systems that we use daily, and we don't even consider that as a problem. This has historically been the case that router vendors would put, in order to save $50, they would put twice less powerful components inside of the node. Thank you for doing that, but you get what you pay for. This mentality is mostly gone. Today, it's clearly understood that the control plane is a heavy task. You need to have sufficient compute power available for majority of the tasks. Purely cryptography may boil down to be not necessarily rounding noise, but somewhere closer to the bottom of your profile graph. The overall path of the AS path, the signed AS path, is considered if strictly all elements and signatures are valid. The outcome of that, again, is fed into the policy. The outcome is binary. The path is either valid or not valid. We don't have any third intermediate state just because cryptography is binary. And if the signed path is present there, you will come to one or to the other outcome. What is required from the RPKI infrastructure and what's the load on the RPKI infrastructure? Now, you are signing locally. The private key is contained within the router. You don't need to consult anything at all, and that's again by design. You don't want to share the private key with any other entity. The way how the private key gets into the router is another problem. It's not a problem as such. It's just outside of the scope of BGP-SEC. Now, for the rest of the world, in order to validate that, they need to have the corresponding public key. That public key is stored in the RPKI infra. Well, in some new objects, which eventually get into the layer of validators, the validation, basically the crypto chain validation happens there, and the end result is fed into the routers. From a scalability point of view, we might run into a practical problem. If we are talking about a fully autonomous system, that means that each and every router in the world would need to have public keys for each and every other router in the world in order to do on-the-spot validation without consulting any other entity. That clearly is not scalable, and that does not work. The way how this is operated is that you don't need to have each and every public key of anyone else. You need to have only those keys which are relevant. That means that this is basically a bidirectional communication. You can request what keys you need, and then you, after some time, this adds to the overall convergence time. You get those public keys fed via RTR. And it's up to the router to decide how many of those to cache. Again, this is not a protocol decision. This is purely a systems engineering decision. You look into the amount of resources that you have available, and you just plan. Certainly, there would be lousy implementations that would overflow, cause all sorts of other resource starvation problems. That's not a fault of BGP-SEC. That's a fault of those who implemented that in a simply unprofessional way. How to design BGP-SEC into your network? The first thing, BGP-SEC has a meaning, and from a cryptographical point of view, has the attestation end-to-end. That end-to-end does not necessarily mean end-to-end with regards to the global interconnection graph. But BGP-SEC does not allow for segment to be terminated and then recreated, continued at some point later. It needs to be contiguous. Even if it covers only the portion of a global connectivity graph, it must be contiguous. The reason for that is that once you terminate the signature, then there is no cryptographically verifiable way to restart that. You cannot assure that there isn't anyone in the middle trying to play some game. So basically, we are coming back to the same spoofing. You either can spoof an ASN, or you can spoof the prefix, because that is not covered by the already terminated BGP segment. So the important aspect is that you design it end-to-end within your domain. It can be deployed incrementally. Both direction-wise, you can only sign an advertised signed prefixes, but you receive those unsigned. You can also only validate. You can do validation as a proxy for the previous hop. You can offload it to some dedicated verification component or something else. Basically, it doesn't require to be symmetrical operation all the time. It's also, again, not, it doesn't require to be applicable on all the prefixes. You can choose a subset of what you want to sign and validate. The fact that it fits into the exchange environment and basically allows to actually see the particular AS hop that was there in the middle is certainly a huge plus from the practical operational point of view. If you paired multiple exchanges, you would certainly appreciate that. Now, a little bit about what a security mechanism can leak. BGP-SEC signs on the router. And the signature is a derivative. Basically, signature is generated by the private key. So if you have different private keys, you will need corresponding different private keys in order to validate those signatures. And the identifier of the private key, not the private key itself, just the identifier, which is a hash function out of the key, is carried together with each and every signed ASPath element. That means that outside of your domain, it is possible to determine which particular node has signed that prefix. You are basically leaking certain topological information inside of your domain. Now, what are the options? If each and every router has individual private key, each and every signature will be distinguishable. If each and every router has the same private key, which is absolutely legal way of using it, each and every update will have exactly the same key, public key identifier. And from that perspective, it will be indistinguishable outside of your domain. If you do something in the middle, well, then there probably will be groups of routers that have the same private key. It comes down to the key management and overall network design. If you use one private key and that private key is compromised, then all of the nodes which use that private key are compromised. This shouldn't come as news. This is just, well, basic security hygiene, basic public key crypto system usability aspects. If you use individual keys, then if some particular key is compromised, only that particular router is compromised. In the middle, if you do something in the middle, well, basically this is a network design aspect. What risks are you willing to take, and at what information disclosure level observable from a site? Now, talking to the operations community, some are very concerned about this. But once they realize that there are other sources that are leaking left and right, probably it doesn't look that much alarming. Others simply don't see that much of the concern. So this is something that you need to know, to understand, take into the design decisions, but this cannot be seen as a drawback or a benefit of BGP-SEC as such. What might be more complicated is how you distribute your keys, private keys. Remember, this is not your RPKI infrastructure. You certainly do not want to put your private key into the global RPKI. No, please don't do that, because well, the rest of the world will certainly be happy, but you probably won't be. Now, there is a notion of key beaconing, and in general, anything related to cryptography has a lifetime. Even if your topology is stable, if your key lifetime expires, you need to re-advertise your prefix again. Regularly, BGP would not do that. Here, even if you don't have topology change, if you generate a new signature, the signature numerically will be different. And your upstreams will receive another update, and they will not be able to tell, well, actually, they will be able to tell that this is exactly the same prefix, but the signature might be different. They cannot reasonably say what was the reason for that, whether that was an update or whether that was a topology change. Therefore, with BGP-SEC, you might see a larger amount of topological propagation or fluctuations, probably the right word would be. How bad is that? If you put your key lifetime to 5 minutes, you probably don't want to do that. Well, rather quickly, probably your upstreams will have a word to you asking not to do that. If you put that lifetime to 5 years, you probably don't want to do that again. It might be cached somewhere, stale, and again, this is no news. This is something that you do with any other key expiration systems which deal with key expiration. And again, probably the most contended part of BGP-SEC. Crypto is expensive. It's not cheap, that is true. How expensive is that? First, you have the static component of cryptography. Basically, the types of hashes and signature schemes that you need to do. Then you have a dynamic component. How many times you need to redo the static part in order to cover all of the dynamic topology and to get it converged. So this has some superlinear properties. The longer the S path gets, the longer the message you need to hash. That increases the cost. The longer the AES path is, the longer again you need to calculate the hash for validation. The way how elliptic curve cryptography works, validation is computationally more expensive than signature. It's the way than the RSA crypto system works, where signing is more expensive than validation. Realistically, we are talking about noticeable computational load. These days, again, if we are talking about the contemporary platforms and not some ancient MIPS R4000 from your Cisco 4500 under the rug, this is no longer a concern. Even at the full scale of the routing table, we will actually have some fun experimental convergence numbers. I just want to keep the fun part for a bit later right now. So if we look about the deployment, the first realistic area where BGP-SEC is going to be deployed, well, I'm saying is going, probably is likely to be deployed are exchanges. For two reasons. First, it's a limited domain. So you can have the end-to-end signature capability from one member of the exchange to the other member of the exchange crossing the route server. So that's basically two hops. The other important aspect is purely from a troubleshooting point of view. This allows you to still have the same policy operation that the path via the exchange is shorter, but that path starts to be visible. Actually, it can be visible in the updates. It's present there in the signature, even that it is not taken into the account of the AES path length. And certainly there are not too friendly neighbors at the exchanges. There are attacks from one member to the other. Certainly that's a reality. Therefore, there is a practical need to have some security mechanism which is granular and which is basically strongly verifiable. Yes, there's a cost. Certainly, this would require changes to the infrastructure from a route server perspective. This would require probably much more capable platform because the amount of state that would need to be accumulated, that's accumulated at the exchange that needs to be processed is condensed, and even at a short segment length, that's quite a lot of signatures to generate, mostly driven by the large fan-out ratio. If we are talking about hundreds of neighbors, we need to replicate the same update hundreds of times. If we're looking into the vendor landscape, vendors don't see that much traction from the field, and they are in passive investigative mode. Yes, some of them are looking into that. Some of them have something like prototypes, but we are nowhere near the shipping implementations. And personally, I would not expect to see this changing in the next couple of years, definitely. Probably by the end of this decade, we might see some movement, but unlikely that this would happen sooner. Again, probably the first deployments will happen on the exchange side and driven by the members who have their own custom peering edge platforms and don't rely on the commodity vendor hardware. If we look into the overall grand vision of where BGP-SEC is going, so what was the initial vision that it will be end-to-end across the global connectivity graph? No, that's not going to happen. First thing, not needed. Second thing, probably prohibitively expensive computationally, even if we are taking into account all the possible optimizations and then changes that we will come to in the last part of this talk. First, now, one other important aspect. Now, so you see me here on the stage talking about the BGP-SEC. And I spent probably half of this presentation talking about BGP-SEC and mentioned ASPA only occasionally. Don't get the impression that I'm against ASPA, or in general you should be against ASPA. No. If you look into the overall path validation, these two solutions, they are required, they complement each other. And on top of that, you need origin validation. So in a grand scheme, well, where unicorns are flying out of routers, you need to have all three of them. Today we don't have unicorns flying out of routers, just gray rats sometimes, so we don't have BGP-SEC yet. This eventually will happen, or likely to happen in some form of that, probably starting in some limited domains. Globally, maybe before my retirement, well, maybe, but I wouldn't be too certain. And I think I still have got some runtime. What is important, though, if you are starting to design your new infrastructure and you are start considering about some cryptographically verifiable control plane security there, you need to take into account what can be disclosed of what you don't even think initially. So that same situation of signatures identifying the node which generated those signatures. Yes, that's by design. You cannot do anything against that. However, if you are in an environment which might be sensitive to that, you simply need to be aware of these types of things. So this leaves the boring part. Then we will have some fun numbers and even some fancy graphs. But before that, somebody would like to disagree with me. Well, I see somebody over there at the back of the room who probably, yes, you, who would probably like to disagree with me. I see one gentleman over there who certainly is willing to disagree with me. So please, come and disagree with me.
So, Ignas, in generally, we agree, as you know, we have discussed about this a lot, many times.
Don't disclose the secrets, please.
No. My name is Lefteris Manasakis from Thousand Eyes, Cisco Thousand Eyes. Hearing you speaking about BGP-SEC, although, as I said, we have discussed this before, I think people would be interested in knowing why you think this has never been adopted up to now, although the protocol specification exists since 2017. The discussions in ITF are much way before that. And when do you think it will be implemented eventually, if it will? That's a couple of questions that I had. What can we do in order to help the adoption is another question. And one thing that concerns me a bit, I don't think we have discussed this, is the number of updates that you mentioned. Whenever a new AS path gets signed again, a new update needs to be created. What is interesting with the number of AS updates is that although the number of prefixes, the number of ASs has gradually grown a lot the last 20 years, the number of updates has relatively remained static, and this has helped in routing stability a lot. And we can discuss why this has happened. There are a lot of theories around it. If the adoption, let's imagine, in a unicorn space, as you described, that BGP-SEC is universally adopted, what is the number of updates per day that we should expect in this scenario? Because this can cause a lot of instability and can cause more problems than it solves.
Excellent. Well, I think I forgot what was in the second question, but I'll answer the first one. There's a whole section about that, so please wait a few more minutes and we'll go into the details on that. Now about the stability. There are two changes to this. Basically, two changes that BGP-SEC would bring in. One is that you introduce a concept of beaconing where you need to basically renew the keys or simply renew the updates just because of a lifetime expiration. This is controllable. But this is needed at some point up to some granularity, right? And my view is that industry overall will come down to a set of recommendations of how how frequent this should be. Suddenly, this is tied to how frequently you change your keys and possibly BGP-SEC objects. So this comes down to the operational aspects, how often you need to change this type of information. Now, another aspect into the overall number of updates is how wide is the fan-out ratio. The way how BGP-SEC is specified right now, it needs to generate a new update for each and every prefix. That's scaling in one direction, and needs to generate an each and new prefix for every neighbor to which that is advertised. Both of those two, they provide the main basically security assurance properties of path validation in context of BGP-SEC. You can do certain things to optimize that. Like, for example, carrying a bitmap of which of the prefixes which are in the signature are actually used for the signature. So you retain the packing, but at the same time you indicate which out of those prefixes which are in the update are live, so to say, are used for the signature. Such schemes do exist. Well, they exist mostly in theory, but at least that theory has been proofread and probably verified. Without the proper deployment experience, today it's quite difficult to say, because if we do some estimation, we typically do that estimation on the current existing platforms or platforms of 20 years old, right? So it makes absolutely no sense to take your 7200 NPE G1 box and try to do the hypothetical performance validation of how BGP-SEC will converge. It will not converge. Well, that platform is obsolete. Forget it. There's a very clear trend in the industry of moving into the commodity hardware and basically software-based control and data planes. So today, if we look at the contemporary compute platforms, there's more than enough compute power. The limiting problems are with memory bandwidth. That's still a very painful problem, and I wouldn't foresee that going to be solved anytime soon. The computational power increases way faster than the memory bandwidth. And for these types of use cases where you have to deal with hashes, right, you are limited by the memory bandwidth and not by the computation. But even with that, the raw performance available for generating the signatures, spreading out the updates and feeding that into the network wire, it's many orders of magnitude higher than majority of the BGP-SEC performance tests done, which are published and available right now in the literature previously. So from that perspective, I wouldn't be too much worried on the raw performance only. What we don't understand right now is basically the dynamic properties of the system. Fine, we do have an exchange. Exchange has 500 members. That means the fan-out ratio is 499. But that's only one hop away, and that's it, right? We are definitely not talking about feeding 500 times with a hop length of 10, where you would need to multiply recursively by hop length by 10, and then by 500 members, and then by 940,000 prefixes. In theory, yes. In practice, this is not needed. The convergence doesn't come as free, of course. It will impact the convergence. I will have some optimistic numbers further along. Right now, I'm just providing you a very brief and condensed answer to a very complex topic, which would require probably a full day of discussion.
Just one more thing to add. How can we stop like 100 operators who do not understand perhaps how BGP-SEC works and change their signatures every 5 minutes, every 10 minutes? And on a global system, this can cause instability.
And it will.
And it will. How can we stop that from happening?
By injecting them with a clue. And that's exactly what we are trying to do here, spreading the clue, spreading the awareness, how these technological components work and at what cost. That's precisely why we are having this discussion. yet, even if we are not going to deploy those things tomorrow. Right, I will give you a personal microphone.
Thank you. So how many questions do I get?
Well, depends how well you bribe me for the answers, but I think we can come to an agreement. Yes.
So the practical one, the IXP use case. If I understand correctly, BGP-SEC has to work end to end.
Yes.
So if I'm exchanging my prefixes through you with him, that's perfectly valid.
Yes.
But what if I have customers and I want to exchange customer prefixes with him? Then all those customer prefixes also have to be signed, which means that my customers must also run BGP-SEC, correct?
That's one of the ways how that can be done. You can proxy sign that for your customer.
So I can proxy sign.
Yes, you can proxy sign. So what does proxy signing mean? What proxy signing means, right? So if you are security concerned, whenever you hear the word proxy signing, say, no, 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 that's bad. But if your customer trusts you and you control your own environment, how that is different than if you were advertising those prefixes. It's not different. The only thing that is different that it has slightly different AS path.
I am accepting the traditional AS path from him, combine that with my AS number, and then I sign the whole thing as the BGP-SEC AS path.
You sign two segments with your key.
Yeah. So instead of signing one segment, I'm signing two.
Yes, yes, that's one of the ways how that can be done. Your customer might provide their trusted private key to you. That's also an option. Basically, this is not a BGP-SEC as such aspect. This is a network design question, and this is also an implementation aspect. What your favorite vendor allows or doesn't allow for you to do.
Oh, let's not go into that.
And same thing for validation. You don't need to rely that your end customer, suppose you have a symmetrical setup. Two pairs, route server, and both have customers. So you proxy sign, and then you proxy validate and propagate to the other customers. Well, not you, but the remote member.
Then I think you hinted that the validation could be offloaded to someone else. Is that a reasonable way to set things up? And what do you do with the incoming update that hasn't been validated yet at that point? Do you just sort of keep it on the side in the BGP table and it's invalid?
So this is to the second part. This is an implementation aspect. You basically mark it as pending resolutions, same as you do with next hops sometimes, right? When you have an update, but next hop is not yet resolved. Right? Now about offloading. I'm certain you are aware of widely deployed solutions where you offload the whole control plane to some node. That's exactly the same thing.
The last, just a snarky remark. With the key beaconing, you effectively turn BGP into OSPF, so I guess.
To an extent, yes, and therefore you need to be careful.
Yeah, thank you.
Thanks. Right, colleagues, any other comments, questions, and discussions? Yes.
Hello, Vasilis Kotronis, Thousand Dice. I have two questions. One is how operators can practically monitor BGP-SEC if there are integrations with BMP or similar, for example, to get counters of cached keys or invalid paths during the last X minutes. That's one question about monitoring, specifically in real time, if it's possible. And the other one is if there is provision in specification, what is going on when a router has to rotate its keys for security reasons, because the paths during that time will be invalid from the perspective of the entire world. So is there any specification on this, on how it's handled practically?
Right, so let's start from a second part, from a second question. Well, I operate in a stack mode somehow as it appears with questions. Right, how do you rotate the key? You ensure that a new key is present and available and ready to be used before your old key expires. That's basically outside of scope of BGP-SEC. That's just key maintenance, both for public key and for private key. Certainly, BGP-SEC will not be happy if it cannot find the valid key. That's by design, right? So if you didn't ensure that the new updated key is valid and available beforehand, please don't blame BGPSEC. That's not its fault. Now about the monitoring. So if you look from a BMP perspective, that's just now if we are talking about well, both mirroring and monitoring. So from a BMP perspective, that's just another BGP message. You take the full message with all the attributes untouched and you send it out and you process it as any other BGP message. For the counters, there definitely will be dedicated counters. Typically, that will be in the domain of the platform specifics, whatever the platform exports, right? Whether it says that this policy is valid, not valid. When we will come closer to the deployment perspective, probably there will be BMP extensions for basically specific standardized counters. Right now, as we don't have deployments beyond the actual message mirroring, it's not there. It's simply not yet ready. But there are no principal limiting reasons why this would be complex to do. Yep. Anyone else? So everyone is ready to deploy BGPSEC right now, yeah? Okay, let's look into some fun things. Where's my clicker? My clicker doesn't want to work anymore. And it doesn't go forward and it doesn't go backward. May I ask for our slide master to advance to the next slide, please? Well, let's stay on this slide for now. Right now it is showing some fancy, well, you see there's a small unicorn, so hopefully that will fly out of some imaginary, over there, right, beyond the X, the letter X. So, there was some experimentation done a couple of years ago, 3 years ago now, in an environment of an exchange. What it would cost, or basically what it would take to try to deploy BGPSEC in that particular environment. So the environment itself, it's a medium-sized exchange, 500 members, half of them full feeds, half of them smaller than that. It's a realistic, basically, it's a synthetically generated realistic traffic profile. Scaling-wise, it's a private implementation that, excellent, it works now, thank you. It's a private implementation that was done mostly for this purpose in order to sense what would happen if we try to deploy BGPSEC, well, basically 2-hop BGPSEC in such an environment. We cannot claim that the implementation itself is top of what is possible performance-wise. However, the important attention was paid purely to software optimization, well, basically proper software engineering in order to do that. Outside of that context, those results probably don't have much of a practical meaning. They are mostly for the illustratory purposes. On the other hand, both the implementation aspects and the purely computational platform aspects have moved since then. The results would be somewhat different, but the ratio between the results probably will stay the same. So, in that environment, 500 feeds to converge. Converge means first update in to large update out when the topology is stable. That's a bit over a minute. With BGPSEC, that takes over half an hour. It converges, yes, but probably that wouldn't qualify to something that is practically deployable. Why? So if we look into the specifics of the current compute platform, so basically a regular x86 platform machine. You have a lot of computational power. That thing can calculate, basically finish infinite loop in less than infinite amount of time, absolutely guaranteed. So purely for computational tasks like signatures, long integer operations, and anything that doesn't require access to memory, well, basically you are limitless. You really need to look hard in order to find network control plane related tasks that would eat out the raw computational performance available. However, with memory, that's a very different story. Memory is painfully slow. The memory bandwidth is very much limited, and for these types of tasks, you also get bitten by the memory latency. And this is not going to improve. If we look in the absolute terms, the numbers might look nice, but if we look into relative performance increase, memory performance actually is decreasing with time. So if you look into the yet another generation of commodity memory, that, unless specific optimization measures are taken into account, operates slower than the previous generation, and that's by design. Therefore, what is important for these types of control plane implementations? First thing, be friendly to your hardware. Don't do things like at the bottom, you will lose instantly. Any contemporary platform today supports vectorization. You cannot find anything that just does not support that. You need to use it. In order to use vectorization, your data structures need to be particularly formatted. And your protocol, the wire image, what goes on the wire, it also needs to be friendly to that. Otherwise, you will spend more time just shuffling bytes back and forth from a format that sits on the wire into the format that is required for you. Running things in batches certainly helps, and that's the way how things should be done. You don't want to validate one signature. You want to validate 100 signatures in one batch and then move to doing something else. You probably increase your overall end-to-end latency a little bit, but you win that with the throughput, not in percent, but in times. So if we look at the internals of how BGP-SEC works on the wire. So from the receive side, what you see there in the diagram is basically how the bytes look on the wire. Well, we have the key identifier, we have the S number, and we have the signature itself. That's all 100 plus or minus bytes. Nothing special. Then the current specification for BGP-SEC uses SHA-2 for hashing. The signature is calculated not on the message. The signature is generated on the hash of the message. That's a common approach in all cryptographical schemes, and that's by design. Of course, it's a slow operation, and also you want to have a certain level of determinism. You take the long message, you compress that with the hash function into a fixed length block, then you sign that block. For signature, that's well, standards-based Edwards prime 256 curve, elliptic curve, which requires quite a lot of computational power, but it doesn't deal with memory. The hashing deals with memory, and that's where the limitation is. If you look at those 2000 seconds performance-wise, majority of the time is spent dealing with getting the right data structure into the right amount for calculating the hash of the signature. Calculating the signature itself takes less time than the hashing. So this comes as one of the limiting factors for the protocol design. If we look from a practical implementation on the vector side, you can do multiple runs, 8 in majority of the implementations, for free. Vectorization is available on all x86 platforms, all relevant x86 platforms. It's available for free. You have already paid for that, but you are not willing to use it. That's your fault. In order to use this, you don't need to add much effort. However, you need to ensure that your data structures and the wire image, what sits on the wire, is friendly to the vectorization as implemented in your platform. And here in the green, you see hashing. So basically, we have different length blocks. That's the recursive hashing. And then in yellow, you have the key signature. It's not necessary to full scale, but the time-wise resource allocation looks pretty much like that. And with vectorization, yes, you lose roughly, well, tens of % throughput-wise, but you gain multiple times of the performance. That's definitely worth if you are concerned with any high-performance, not only control plane, any high-performance data processing. Now let's look at the painful things. The way how the message is located on the wire and the way how it is needed to be processed is very different. The reasons why that is done, there are two. One, it is theoretically nice in the sense that at the BGP-SEC design time, the focus was on making the cryptography right. And yes, it was done in the right way. However, the oversight was not to look into the practical aspects. The second thing, 20 years ago, both the availability of available commodity platforms were different. Vectorization was mostly a domain of very specialized hardware, definitely not what was used for control plane for commodity routers. And it was simply not taken into account. Today, that's basically a grave mistake. The reasons why. The SHA-2 hashing, it operates on 4-byte elements. Here on the wire, you see things spread in 72, then in 6, then in 20 bytes, and scattered around. You need to reshuffle back into one logical buffer. Oh, well, you can do the GAVA type of operations, which are yet more expensive. And overall, you lose for nothing. You have a really performant platform, but the data that you feed into it basically rules out all the possible performance benefit gains. So this is a limitation of basically this is an impact of a protocol which was misspecified. It was specified in abstract BGP-SEC in a vacuum, but once you try to run that on some concrete platform, you realize that it completely conflicts with it. If you look at the transmit side, remember from a previous slide, BGP-SEC signs also the forward AS hop. The problem with this is that the forward AS hop is located in the very beginning of the message that we are signing. So that means that if I have 100 neighbors to whom I need to advertise this prefix or this particular AS path, I will need to calculate 100 hashes. Why? Because the first 4 octets will be different every time, because I'm advertising to a different AS number. If, however, I move the AS path to the end of the message, just like that, just reposition the 4-byte field, I calculate the hash once, I cache it, and I reuse it. Yes, I still need to calculate 100 signatures, but as you saw previously, calculating signatures is substantially less expensive than calculating the hashes because it doesn't touch the memory. The protocol specification doesn't allow me to do that. A simple oversight, right? But that oversight was discovered only when somebody tried to implement that, ran some performance testing, and got a rather surprised look of the results, right? That is one of the reasons why interoperability testing of what is coming from all sorts of technology standardization organizations is certainly needed. So that same implementation, just changing the wire image. We'll call it BGP-SEC version 1. Quite a noticeable performance impact, and this is something that I would call an acceptable price. Waiting for 5 minutes instead of 1 minute for your medium-sized topology to converge probably is an acceptable price to pay. At the cost of making the protocol just be friendly to your contemporary hardware platform. This gives a loaded question. Is BGP-SEC broken? Basically, is there a future in it? No, it's not broken. It's just substantially suboptimal. The good thing about that is that we can fix this. As there are no deployments of BGP-SEC, we are not concerned about breaking the compatibility. And yes, we must break the compatibility because those changes which are required are absolutely incompatible on wire with what is specified in the current specification. There is a level of extensibility. The fields are versioned. There are identifiers, code numbers that you can use. There's even some level of backwards compatibility. Going deeper, there are some other, say, leftovers from 20 years old state of the art as it was at the time. Purely from specification point of view, how certain things could be done optimally or suboptimally. There's also a requirement to do some slight modifications to the core BGP machinery, mostly for well, signaling and housekeeping, nothing complex and nothing related to security. But would be good to have also for a broader set of functionality. Now, with all of this, if we take a reasonably smart compiler, can it do the magic? No, it cannot. We are not talking about purely code rearrangement type of things. We are talking about the data flow dependencies. The compiler cannot do that and will not be able to do that. That's outside of its basically authorized domain of influence. And at the same time, we are talking about a wire image. We are talking about interoperability between the two systems. Certain things can be optimized, but only to the level. And if we are talking about the performance, this needs to be fixed first. Right, if we rewrite this in whatever programming language is fashionable today, right, will this give us a huge performance boost? No, it wouldn't. It's exactly the same thing as we have with the first part of the smartness of the compiler. There is a widespread, I would say probably even a religious fight that this particular language is bad because it is insecure by design, and this particular language is new, modern, and fancy, and therefore we should rewrite all of that critical infrastructure using that. And then 2 weeks later, this new shiny things comes in, and we need to rewrite that once again. Certainly, that's a fun exercise to do, but if you look from a practical point of view, programming language is a tool, nothing more. It doesn't decide anything. If you think that there are security problems in the code that you write, first you need to look into code that you write. Don't blame the programming language and the compiler for what you do. Often I hear, so you're talking about this fancy vectorization thing, what's this exotic type of hardware that is required? It's not an exotic type of hardware. You cannot buy anything on the market today that doesn't support vectorization. Well, you can buy something that is used probably, well, in the air conditioner control panel over here on the wall. But all the contemporary compute platforms that would have enough of a capacity to operate in this environment have that by default. Get it, use it, and be happy. Memory system overall is not going to evolve in a very positive way. Overall, memory is getting slower, and the cost of accessing memory is increasing. Yes, we have larger amount of memory. That does not necessarily compensate for the performance that is needed for this particular task. Yes, I'm talking here about a rather deep, low-level technological aspects, but again, BGP-SEC doesn't run on a spherical unicorn-powered routers in vacuum. It runs on real platforms. Real platforms have real limitations. You need to take into account that when designing protocols and systems. That's important. And this gives the summary, basically the assorted talking points of all things related, mostly BGP-SEC. I think I covered most of that, at least touched into that. Right, what we are doing with time here. Anyone willing to rush for lunch? If so, I won't be standing in the middle, but yes, I see questions over there. Excellent. Let's have a discussion. And if time permits, we will then finish up with the wrap-up slide. Yes?
My name is George Tubanis. I want to make a question about the RAM that you said, the memory, basically.
Yes.
Like modern processors, they have a lot of cache.
Too little. Way too little.
What do you mean? Because if we have, let's say, 2 epics, it can be like up to 1 gigabyte. Is it not enough?
That's way too little. We are talking about hundreds of gigabytes of the working set here.
For all the time?
Yes.
Okay. That solves my question. Thank you.
The other thing is cache is washed and contended by all sorts of other things. The fact that you have 2 gigabytes of cache doesn't mean that you have 2 gigabytes accessible all the time. Cache is line-based. That means you don't have 2 gigabytes of really usable space. You have probably 1 at best because you need to align your data structures. There's certainly a slack that you don't use it at all, yet that occupies the memory bandwidth. It's not as optimistic as marketeers would like you to see. Excellent question, by the way. Right. Anyone else would like to disagree with me? No? So who would be willing to go and deploy some BGP-SEC now? Right, let's wrap up with this summary of the things. So maybe then a little bit of what to expect. So you might say that I criticized now of what has been designed here. What needs to be done? We need to move to a new wire format. That's a rather simple thing, and that gives you a really large and noticeable performance increase. We likely need to move away from Weierstrass to Edwards curves. That's what the rest of the crypto world is doing. So all of the browser networking vertical is moving into that, and for good reasons. They don't necessarily give that much of the obvious performance benefit, but generally that is good for commoditization in the industry because we certainly will have multiple, we will require to have multiple implementations of this, and taking off-the-shelf components is way simpler. We also need to move to another hashing scheme, probably Blake derivative or something like that, which has both better per element performance and is friendlier to blocks of varying sizes. Those are deep internal implementations aspects. From a protocol perspective, it appears that nothing is fundamentally broken with BGP-SEC. The fact that it hasn't been deployed is not the fault of it being wrongly designed. It just doesn't solve. First thing, it was ahead of time. It was definitely specified way before we as an industry, as a group, understood where the problems are. Initially, it was thought that we will need to have an end-to-end strong security. No, apparently we don't need that. This is yet another good example of good enough. That something that started with origin only, then moved slightly into a domain of path validation, it's good enough. Now, as we gain more understanding and experience and the requirements are growing, we need to look deeper, further ahead, and BGP-SEC is certainly the right thing to do. Beyond that, and then beyond some other maintenance type of changes in a BGP-SEC, we don't see that it needs to be redone. So in summary, BGP-SEC is not broken. It's suboptimal today. And if we run about these same questions, well, probably I will leave that as a task for you to think through that and see whether you have changed your answer that you had before coming to this session. Don't be afraid of BGP-SEC. That probably will happen at some point in time. It won't going to happen soon, but we need that. The way as our understanding of routing security is today, we certainly need that. So with this, let's move to the discussion part. That's mostly it from my side. What I would like to hear, comments from your side. Have you experimented with this at all? Do you see the problem space real and possibly painful? Do you at least have an opinion about all of this that I have been talking here about, and whether that's at least remotely applicable in those environments in which you are dealing with? Now, and also on a serious note, I would like to get some feedback on the overall level of this. As well, during the break, I got some feedback that this is a bit too complex. How did you find this? Was this of any value, interest, and applicability, or was this just yet another unicorn generator from stage talking about some science fiction and routing? Right, the microphones are all yours, please. Any feedback? Yes.
Hi, this is Haris Alatas from IIP. I would like to ask you, looks like BGP-SEC is still in the early stages of, people are not using it yet.
Yes.
But looks like there is a case with maybe the hardware in the routers. But it's not, I don't see it's a CPU power that is missing here, but rather than a specific cryptographic power that is missing from the hardware. Is this going to be settled somehow with specific chips that can handle this load?
Not really. There's nothing specific that would require a specific crypto accelerator. When I was talking about the vectorization, that has nothing to do with specific crypto load. No. The overall additional load required is minimalistic. It adds up. The fact is that you have to do the same operation over and over on basically on hundreds of millions time scale, and then each 20 nanoseconds start to count. Doing offload, we are not talking about a data plane here. So doing any crypto offload is, well, basically is not needed at all, and that's completely different scale of a problem. From a purely computational point of view, what is specified right now is just a general purpose compute task. It doesn't require anything special, and it's not complex at all. It's the sum of how the wire image is done very suboptimally. You need to spend more time to prepare that for the actual crypto operations. And the crypto accelerator would not help you at all for that. The crypto accelerator has even stricter requirements on the layout and then how that needs to be provided to it. So no, you don't need any specific hardware for this task. Now about the performance. 20 years ago, all of the vendors certainly were very reserved about computational performance estimations. Today, the situation is very different. First, we see a very clear trend of moving away from custom to commodity platforms. Well, basically, even the data plane is a software base today for many of the deployments, and specialized networking hardware becoming to be the minority. Certainly, if we are talking about the host-based networking, there is not a problem of processing capacity at all. You have more than enough of it there. If you are talking about some specialized hardware, what we might call white boxes or some other marketing name, generally you also have more than enough compute capacity over there. Memory probably is, the memory size probably is a limiting factor. Memory bandwidth is absolutely the limiting factor, but you cannot do much about that. That's just the laws of physics. And that will continue. Therefore, you need to invest into proper software engineering to take that into account. So basically the data structure layouts, taking into consideration the geometrical addressing of the memory and things like that. Well, basically deep low-level software engineering. Nothing fancy, not too trivial, but something that you need to take into account very seriously. Beyond that, personally, I don't see much of a concern that the generation of the hardware on which BGP-SEC will be run will have limitations. We are not talking about what we are deploying today. Realistically, we are talking, well, in the most optimistic cases, end of this decade, so plus 5 years from now. The platforms that you have deployed today will be on the edge of being obsolete from 5 years from now. And it's not evident that the trend will reverse, moving away from a software-based platforms only. So from that perspective, I don't see a concern about the compute as such. I do see a concern of how we use that compute power. Yes.
Yeah, I'm Qasim Lone. I work at RIPE NCC as a senior researcher. First of all, the feedback, I think it was very informative. I really liked the presentation and a lot to learn from the presentation as well. So thanks for that. I think you partly already answered the question that I had in mind, but just to take a step back as well, where do you also see the pain points? Is it also, and the role of, for example, standardization, so RFCs, do you think they are following up with how the technology should be moving other than the overall movement in this space?
I would wish. Sadly, that's not necessarily the case all the time. Overall, so standardization, it's not that much of a complex task to fix these problems. The far bigger problem is to persuade those who sometimes do denial of service on a standards development level by not understanding or intentionally, and also of having more real-world implementation awareness in the standards bodies. That it's a similar or mostly basically equivalent problem as we have with operator representation in standard bodies. Now, you here in the room, you run these things, right? You see the pain points and you know what is broken and what is not working. But your feedback doesn't necessarily get into those environments which deal with what will eventually come back in the pipeline for a few years from time, right? So basically into the vendors and to standard committees. Exactly same thing is from a vendor side. They implement, they see the pains of implementing it, but they don't necessarily feed that back both into the user community of how to avoid those and into the standardization community. Just because that these communication channels typically don't work. So yes, the concern is real, and we probably wouldn't had this conversation if BGP-SEC were to be specified, taking into account all these implementation performance aspects at the time. Yes.
Yeah, Tim Reisers, RIPE NCC. I have a different question, actually. In the beginning, you talked about data. So BGP-SEC uses keys in the RPKI to communicate keys through the RPKI so that you can do signing and validation. An idea I've heard from time to time is that keys could also be used on BGP sessions between peers. Is that something that you've thought of or have thoughts of?
Right, so that's different. That's basically a different layer. That's transport security, yes. There are such ideas floating around. Technically, it could be done. The question is, what problem does it solve, right? Well, many things can be done. It does not necessarily mean that they should be done, right? It's a nice engineering challenge or academic challenge, having nothing against academics or engineers, right? Research is a fun thing to do. But if we are talking here in a community of, well, practitioners, those who are dealing with practical problems, probably you wouldn't be too interested and too happy if those resources are being spent on some academic experiment of how certain things could be done in theory. So in RPKI, we can distribute routing policy to routers, certainly. Well, just make another object. Why not?
Yeah, so my question was really, if I can rephrase it, if there is a good use case for doing this. And if you say no, then that answers my question.
So from my point of view, the way from where I do look, I don't see such a use case, although I understand how it could be done. We can invent a use case, right? And that would justify all of the work that needs to be done. So yes, BGP is a universal transport protocol. You can carry whatever you want over it, right? So now let's make RPKI the universal distributed and resilient database, right? Right. Any other comments? Any other feedback? Any other questions, gifts? Yes. Oh, a personal microphone. No. You have your personal microphone.
Thank you. Coming back to your first slide, talking about unicorn, JSON-based microservices.
Just
and
a
all
moment.
that.
Yeah.
Yes. I don't have to go all the way back. You're probably aware of all those greenfield, clean slate attempts that say BGP is so broken we cannot possibly fix it. So we will invent something new, like what I have in mind this time is Cyan.
Yes.
What do you think about that unicorn?
So, and that's actually a very good question. By the way, anyone aware here what Cyan is? Yes. So, Cyan is a rather complex project as such. It tries to reinvent not only BGP but global routing system together with security integrated into it. Leaving aside whether the goals are realistic, Cyan basically has two parts. It defines a new data plane over which it's not IPv4, it's not IPv6, it's not MPLS, it's a new data plane. And that data plane carries information elements that are used in the Cyan control plane. Now, the Cyan control plane is something that redefines the notion of autonomous system, adds in what I would call complexity, calls the same concepts that we are familiar with in different and sometimes conflicting names, and claims that this is a solution to BGP routing system security problems. The fact that they define a new data plane and they are serious about that is a concern. You don't invent a data plane and expect that it will get deployed globally in a global network. Look at IPv6, right? It's a spectacular failure of deploying a new data plane. And, well, sadly, we don't have anything better. But clearly, certain groups haven't learned from those mistakes done. What does it mean to define a new data plane? That means that not only endpoints, but all the transit elements in the middle need to be aware of it. I can imagine this happening in some closed environments rather easily. And well, there are plenty of deployments that run private data planes for very good reasons, and that just works, right? But there's absolutely no point and even benefit of trying to push that beyond those limited domains and try to make that global. The other aspect, what Cyan does in the right way, certainly in the right way, is the overall trust hierarchy build-up. They have a notion of, well, basically it's a majority scheme, right? If there's a conflict, basically if you have a split brain scenario, the environment is able to come up to the logically consistent conclusion of what needs to be treated as the current and authoritative source of truth. If we are looking into our world with multiple castles, meaning trust anchors, that's not necessarily too resilient in case when we have, well, Well, if the key of some trust anchor expires or is compromised, well, what you do then, right? Or if there is a partitioning of something, right? The keys do expire, and certainly keys will continue to expire, and we will run into these problems. What Cyan does, they have a rather nice mechanism of, well, call it a voting, where the new leader or the new authoritative source of truth is elected and considered to be trustworthy. So overall, Cyan is a very nice and entertaining read. And actually, first they published the book, and only then they published a draft specification of the protocol, which is a little bit unusual, but the book is definitely a very good read. Just read it with sufficient critical thinking mode enabled, because it paints a rather academically nice and unicorny world, which is a little bit different from something colored in dark, hellish colors of the existing network infrastructure. So, summarizing, I've learned a few things from Cyan Ideas. They are doing the right thing. That's an interesting read. Often, especially in the engineering community, we see Cyan being downplayed. No. They are wrong at their perception that data plane is easy. No, data plane is nowhere near easy. And it shouldn't be. On the other hand, we have plenty of choices for data planes, just reuse that. But from a control plane perspective, I wouldn't call it a viable alternative. That's probably an alternative world as such. Would Cyan move into the, say, BGP routing security ecosystem world? Probably not. There would be huge resistance for that, and probably me including too, for good reasons. But certainly as a source of ideas and as a research in this environment, that's very good. And actually we need more such examples of academia and industry collaboration. So there's another proposal of BGP forwarding commits, again, trying to address the problem space of BGP-SEC in a slightly different way. That's another interesting academic approach to that. Due to the scope being smaller, that's probably a slightly higher probability of moving somewhere. Beyond that, please take a look at Cyan. Please read that. Read that with a critical mode on, but that's an entertaining and enlightening read. So, and by the way, excellent question. So I see the boss coming in here and saying that, right? So okay, I think we are over time, right? I was just walking in. Right. So with this, well, at least I have gone through what I had from my side. I would really like to see a little bit more engagement and interaction from your side. Although I do understand that now on everyone's mind is lunch now, and not this boring BGP thing. So, any final comments? Right. So I will try to bribe you with a portable microphone that you don't need to stand up. Right? Anyone? You want some, right? No, you don't want. I'm slowly approaching to the end of this room, and certainly I know that you will have something to comment on. Of course, my pleasure.
I just want to tell you, thank you very much for this presentation. It was very interesting. I think lots of people learned a lot of things about BGP-SEC in particular. And unfortunately, I was present only in the second part.
Whose fault is that?
Yeah, my concern still remains about the number of updates.
Yes.
Because, you know, we need to find a way to stop people from being foolish. And that's not an easy thing to do.
Absolutely not easy thing.
And we cannot trust that people will not shoot themselves in the foot and essentially the global routing system. in the food. Yeah, but thank you very much. It was very interesting, and we'll keep chatting about this.
Excellent. Thank you. All right, colleagues. So I think that we are coming to our logical conclusion over here. Right, then what? Thank you for attending. Thank you for discussing. Thank you for raising provocative questions. Right, so the most active speaker from the audience gets a virtual prize. Right, so as the prize is virtual, well, there's nothing to hand off, but at least you get a virtual prize. Right, thank you for interacting. And again, well, thank all of you for listening, and hopefully that my propaganda left something for you to think of, and that was at least of marginal value. All right, thanks.
We need to start. I know we're in Southeastern European region, but we still need to start. Okay, welcome everybody. My name is Jan George. I'm the SCPC chair. Yeah, so I apologize for my voice. I've been recovering from a very bad throat inflammation. I hope you understand me. I'm really happy that I have this little bit of voice still left, so I can say welcome. So I'm here from the program committee. These are the members of the program committee. The program committee is set to compose the agenda of these 2 days. So if you are happy with the agenda, come and talk to us. If you are not happy with the agenda, come and talk to us. Tell us how we should do it the next time, and also make the program much better. So Zoran is not here. Bovio is somewhere here. Vesna is here. I saw her. Goran Slavic is not here today. Ivana is not here today. George is, where is George? There? Okay. And Eric Andrei Baleniu, Branimir, Sanel, Vladislav is not here. He's my vice chair, and that's me. Can I ask my PC cats to stand up so you can be seen and wave? So if you are happy or not happy with the program, talk to these people or me, and we welcome all the feedback possible. Okay, in interest of time, for question, comment, suggestions, there are 2 microphones in the room. Please go to the microphone and state your name and the affiliation before making a comment or asking a question. Also, I would like to ask all the presenters not to send slides to the program committee, but there is the upload button on the website where you can upload your presentation. If you don't, and when your time comes for your slot, there will be a black screen. So please make sure that you upload the presentations. I would like to thank the RIPE-NCC staff for all the work. It's a lot of work, and organization efforts put in this event. Also, big thanks to the local host, Lancom, for having us here. And with this, I would like to give the floor to Hish. Hish, where are you? Where's Hisham?
There.
There. Okay. Thank you very much.
Hello, everyone. And while they're pulling up my slides, let me try. Yasos, Kalakala, Kalimera, and Ifcharaso. That's all the Greek I know. So now we got that out of the way. And Upa. Yeah, I know that one. So now that we got that out of the way, I can continue in English. It is very nice to bring the SEE meeting to Greece. This is the first time that we have the SEE meeting here. We've been trying for a long time to bring it over, and we finally succeeded in doing so. And I think I have the clicker. And that is thanks to our local host, Lancom, that made this happen. I didn't introduce myself, did I? Other than Hish, I am Hisham Ibrahim. I am the RIPE-NCC Chief Community Officer. The RIPE-NCC being the organization that you know that distributes IP addresses and AS numbers, but we're also secretariat to the RIPE community, and we also provide information services related to either K-root or Atlas and measurements and stuff. You're going to hear more about that in my talk. But really, it's all about the community and bringing communities together, which is why we're very happy to be here in Greece with one of my favorite meetings, which is the SEE meeting. Now, to support the meeting here, we brought a lot of NCC staff to help make sure the meeting goes well. You will see them around. Here's the names of them. If any NCC staff are around, please raise your hands so that people know that you're in the room. Yes? So a whole bunch of them all over the place. They're all eager to talk to you, eager to understand what you're doing in your networks, what are the challenges, and how we can help. We also have both co-chairs for the RIPE community, Mirjam and Niall. Mirjam, please raise your hand. Niall, yes. Make sure to talk to them and learn more about how to get involved with the RIPE community and the activities that are happening there, the working groups and all the other stuff that's there. We also have two board members, Remco and Piotr, who are not in the room at this moment. I was just talking to Piotr outside. Just outside, but they will make it in a second. If you want to talk to the executive board of the RIPE NCC about anything related to the RIPE NCC, you have an opportunity to do that with them. We have a great program committee. Jan was just on stage now. They put together to you an amazing program. And as I understand it, it was one of the easier ones that they had to put together because a lot of great content was put in early on. So they really did a great job. Again, program committee people, please raise your hands so that people know you're around. These are the people that if you like the agenda, please tell them. And especially if you don't like the agenda, please tell them so that they can make something better according to the needs. Very quickly, some housekeeping. Registration desk, you've all passed by it by now if you have your badges. Kajal and Sandra are there and they're happy to help out with anything that you need throughout the events. We also have a desk for our RIPE NCC Academy. So we have an e-learning platform that people can go and take certifications and learn more about topics like BGP security, IPv6 fundamentals, the RIPE database and more. You can do that through our e-learning platform, but you can also ask them if you would like to host a face-to-face training. We also have those as well and a number of webinars. They're interested in talking to you also about understanding your needs so that they can also incorporate that in the courses that they're building. We also have the NCC service desk. Basically, if you have anything related to tickets with the RIPE NCC, your allocations, your addresses, anything, they're right out there and they're more than happy to take any questions that you have related to anything related to the NCC, but specifically, of course, to the registry. And yes, during these events, we've grown accustomed to having points of contacts in case anything you are subjected to anything at the meeting. Please make a point of coming and talking to us. Anything that you feel violates a code of conduct or you feel uncomfortable with, we do have people, myself, and I think Gergana's in the room here somewhere. Yes, Gergana's in the back there, and Sandra outside. Feel free to come to us if there's anything you want to discuss. And last but not least, social events. Of course, we have some. So today we have a dinner planned for everyone. Here's the information on screen here. And we will make sure of updating you during the intermissions about this. And we also have a closing reception tomorrow. And with that, thank you all. And I hope you enjoy the meeting. Thank you.
Thank you, Hisham. And our next speaker will be from the host, from Lancom. Please.
Good evening. Thank you all for joining beautiful Greece. I would like to thank RIPE NCC for the privilege and an honor to host a RIPE event here in Greece. It was a dream that came true after many years for us. So, as you probably know, Greece is not only beautiful, also has, let's say, it's a destination for vacations. So you probably know that we also have very good food like moussaka, like souvlaki or tzatziki. But what you're going to realize in a few hours, where I also have a presentation, is that Greece has advanced its steps towards a better telecommunications world. This means that many great investments have been announced. I would like to refer to the investment from Microsoft of 1 billion euros for 3 data centers, which was followed by another investment from AWS for 3 another data centers, and another investment from Google for also 3 data centers. On a total, we are talking about 9 new data centers. On top of this, you will also see in my presentation that there is not even a single new submarine cable that is coming from Suez that will not have a landing station in Crete. So this means that all the old submarine cables that were just passing through Greece without even stopping, and we're going to Italy or obviously to Marseille, now things have changed, and this is very important, which means that they have seen something very obvious, that sometimes, obvious things are not that obvious. And this is something that I will also explain in my presentation. So, without saying too many technical things, because I know that most of you would like to see really a deep dive, I will stay here and also take this opportunity just to thank you again for joining this very beautiful event. And I hope that you will have a memorable, how can I say, experience of Greece. And when you leave this beautiful country, you will also keep in mind that Greece is not the way that it was in the past. Thank you all for joining again.
Thank you. Our next speaker is Mirjam Kühne, the RIPE chair. Mirjam, the floor is yours.
Thank you. Hello, good afternoon. Yeah, my name is Mirjam Kühne. If you already introduced myself, I'm the chair of the RIPE community. And obviously the SEE community is part of the RIPE community, so I'm very happy to have the opportunity here to give you a quick update of what's happening at the moment in the RIPE community, in the various parts, working groups, and so forth. So you might see this, but you probably don't remember, but we have a new layout and a new logo that the RIPE community actually has agreed at the last RIPE meeting. And I have to stress, the RIPE community actually celebrates its 35th anniversary this year. And so after 35 years, we have a new logo agreed, and the RIPE NCC has done a great job in designing this together with us. And actually, just not only that it kind of modernizes and updates the look and feel of the logo, and you might think, well, it's just a logo, why is this important? But I think that one of the goals was also to show the collaboration there between the RIPE NCC and the RIPE community. So you see in the middle is the RIPE NCC logo, and it's kind of embedded by the RIPE community, which is kind of the mothership of the RIPE NCC as well. So you will see more of this RIPE logo, of course, in all the presentations and then moving forward. So just to give you a quick update on what's happening currently, some highlights. I can't mention all the activities, but just some highlights of some of the working groups. There in the address policy working group, there was a long discussion about a new policy that has now been accepted and published as a RIPE document 822. That was a policy that allows the status attribute LAR aggregated by in PA assignments, also in the database, similar to what's already possible in IPv6. It's now also possible in IPv4. The anti-abuse working group has started an activity to look at their charter. Maybe they will change their name, maybe have more and more wider focus on security. So they're currently discussing this on the mailing list, have a new scope charter. I'm sure this will be continued at RIPE 88 in a few weeks. Wow. The cooperation working group is always pretty active, and you often see, if you're interested in keeping up to date also of initiatives in the European Commission or other government initiatives, the RIPE NCC and also the chairs of the working group and also participants of the working group are frequently sending updates about initiatives or any surveys or consultations, anything coming from the governments that's relevant to the operators community, to the cooperation working group mailing list. And also the meetings are usually a good mix and a good dialogue and collaboration between technical community and government and law enforcement representatives, regulatory representatives. So there's usually a high level of activity there. A RIPE database had an online meeting, the RIPE database working group, a few months ago, and is kind of going through some of the work items in the working group. So it's not quite policies, it's more like action points and numbered work items that the database and the RIPE NCC agreed to work on. And there was a support recently for a proposal to add sponsored by as an attribute for inverse query attributes. It's a small thing, but it was very welcomed by the database participants. I mentioned this last time. This has started in RIPE 85 already in response to an initiative by the EU, the DNS for EU initiative. And so the RIPE community set up a task force to provide best current practices for public resolver operators, for DNS resolvers. And they almost finished. I was hoping to already give you the RIPE document number now, but it's still in preparation. So they almost finished their recommendations, so their best current practices document. They worked on together with the RIPE community, mostly the DNS working group and the cooperation working group, but also with other groups like OARC, the ITF, and other communities. So that will be interesting for our DNS resolver operators. Now, we've also done a lot in terms of kind of meta things, RIPE governance issues and RIPE governance documents over the last few years. We're documenting our traditions and our the ways we make decisions and various groups in the community. We finalized the code of conduct, as you've heard. We have a code of conduct team in place. We've updated the policy development process some time ago. We have a document on how task forces work, what that means, and similar documents. And we're going through step by step also recommendations that the Accountability Task Force has made a few years ago, and also the RIPE Nominating Committee has made. And so where are we with this? We are currently in the process of updating the charter for the RIPE Program Committee. We identified there are 2 documents, and it's time to update the documentation. And so I'm working together with the RIPE Program Committee on publishing that as a RIPE document. There was a document published not too long ago, RIPE 810, which was one of the recommendations that came out of the RIPE Nominating Committee a few years ago, is to document the role that the RIPE NCC staff plays in the RIPE community. And it was really nice to see a lot of support from the community for RIPE NCC staff. And the document basically is very short. It lists some principles. It basically says the community values the expertise of the RIPE NCC, and RIPE NCC is recognized as an important part of the RIPE community. And on the other hand, the NCC staff, of course, needs to be careful when it comes to guidance for the RIPE NCC. So you don't want to kind of give guidance to yourself. You want to be careful with that, and also make sure all these decisions are done in a transparent way. So that's a really nice base document, and I'm going to come back to that in a bit. We're going to continue to work more on this topic and the relation between RIPE NCC and the RIPE community. We've also updated the election process document for electing members for the Number Resource Organizations Numbers Council, which also forms the ICANN Address Supporting Organizations Address Council. And based on that document, there was a new member elected to the council at the last RIPE meeting, and they're really active at the moment. There were some updates also sent to the RIPE list on a topic related to the accreditation of RIR, of regional internet registries. It's a fairly old document that was set up decades ago by the existing RIRs at the time. There's a really good article recently published on the RIPE Labs blog platform by the legal officer of the RIPE NCC if you're interested in that. Still also RIPE governance, kind of high-level topics. There's a lot going on in terms of leadership. A lot of working groups have issued calls for volunteers because terms of some of the chairs are going to expire at the next RIPE meeting. So if you're interested to more actively participate in the RIPE community, there's an opportunity there to maybe become a working group chair of one of those working groups there. And we're also working together on updating some of the process and how to select those working groups and to kind of adjust to new realities like remote participation, hybrid meetings, and so forth. And there's a really good set of training modules that we've developed together with the RIPE NCC. I'm really happy with these modules. They're very nice, engaging, and interactive, and easy to go through. I think there are about like 8 or so modules by now. And not only for existing working groups, but also for people who might want to become a working group chair in the future. Like, what's the policy development process? How do you go through the process? How do you build consensus? How do you engage with the group, like a working group? How do I best go about becoming a new working group chair? How do I interact with the code of conduct team? All these kind of topics are described in these training modules. And another thing that's starting to, where the process is starting now is the chair selection process. And I should have, of course, introduced you to Niall O'Reilly, who's sitting there. I mean, I had him on my first slide, but this was another clue for me, is because Niall and I, we started like 3.5 years ago, where the RIPE nominating committee chose the two of us as chair and vice chair for the RIPE community. And this process kind of kicks off again now slowly. The RIPE NCC board is appointing the NOMCOM chair, and then in October the new NOMCOM will be formed, and then the whole process will start. And in 2025 in October, our terms will finish, and a new term, a new team will be chosen. Now, as I mentioned earlier already, part of the RIPE governance structure, of course, is also the relation to the RIPE NCC. And obviously, over the decades, I mean, we have developed, and from day one, really, there's a really good relationship between the RIPE NCC and the RIPE community, and mutual support, as in the RIPE NCC provides the secretariat for the community, and on the other hand, the RIPE community provides guidance and support also for the RIPE NCC. And the NCC kind of depends on input and feedback and guidance from the RIPE community. And so we're going to continue to strengthen that relationship and further to document that also. And while going through the process, there is already a lot documented. As I said, we've documented our decision-making processes, updated the PDP, and other documentations. And so I think one important aspect is to promote that more and to explain it more and to make it understandable and accessible, not only for people from the outside looking at our community, but also even within the community and the RIPE NCC, because it's quite an intricate and maybe a unique relationship that we have. The whole structure between RIPE and the RIPE NCC and how this works is something I think we have to continue to promote and to defend and to explain. And while doing that, we might identify some gaps or some other things that we need to address. That maybe have kind of crept in over the time and that we haven't really properly documented, and so we're going to work on this as a next step in our governance, or strengthening the RIPE and the RIPE NCC governance structure. And I think that was pretty much it. Just a few words. Maybe I'm wrapping up and going to to the the RIPE meeting that's coming up. With the new logo, there's also a new website. You might have seen that. Actually, the RIPE NCC has announced that there's a new RIPE NCC website together with the RIPE website that makes it a bit clearer to understand the difference also between RIPE and the RIPE NCC. Comes with its own color schemes and layout and templates. So that obviously helps also to explain the whole structure and the difference between the two organizations. As usual, the last few years before each RIPE meeting, we're organizing an online student event with some really interesting presentations. That's going to take place, I think, on the 7th of May. Well, online, as I said, with some community presentations and it's supported by the RIPE NCC. And then at the RIPE meeting, we also have a really interesting diversity and inclusion session, again, that we've also had traditionally for the last few meetings. That's organized mostly by Vesna, who's there and has some really interesting topics this time. So if you're interested in that. Obviously, the whole RIPE meeting is accessible also remotely. I hope to see many of you there in Krakow in about 4 weeks, but we can also participate remotely and not just listen, but also actively participate and in the discussions and ask questions and so forth. So, maybe I should mention this, the opportunity actually to organize local hubs. Vesna has initiated this at the last RIPE meeting. We had quite a number of local hubs, which means people kind of got together in a university or in an office or even someone's home, so that you don't have to sit behind your screen on your own, but you kind of have a little mini community coming together and following the RIPE meeting with your colleagues and friends, and so you kind of have a bit of a meeting feeling to it rather than if you're on your own. And so we're trying to integrate them also more in the meeting, make sure they're visible, throughout the meeting, and so we want to promote it and support it further in the future. And I think that's it. Try to leave some space for questions.
Thank you.
If there are any.
We are well ahead of the agenda, so we will have. We will have more time for Earn panel.
Yes.
Are there any questions? Please go to the mic if you have any questions. Here we have the RIPE chair, and there is the opportunity to ask her questions. Yeah, please go to the microphone. Yeah, there is walking involved. Please state your name, affiliation, and then ask the question.
Thank you. I'm Shelton Montesi from Priandori Limited, based in UK. I want to congratulate you for the event and for your amazing work that you did as a private organization over the years to bring all the world and Europe especially together, and all this for this success. As a citizen of the Europe's most democratic country, the Republic of Kosovo, I would like to use this democratic opportunity to ask you if you can add the Republic of Kosovo to your country list to make, by this way, 2 million people happy, and by putting the politics out and Kosovo in. Thank you.
Thank you. Yeah, I assume you are probably referring to a list that's published by the RIPE NCC about the RIPE NCC membership, so I will happily pass that on to the colleagues at the RIPE NCC, unless Hisham wants to comment on it right now.
Yes, thank you for your question. We actually have been talking about this to a fellow citizen of yours from the government. And yes, I see also nods from others. So we've been having this dialogue. The short answer is, in the database, we follow the ISO standards that Kosovo does not have a country code in. However, we have identified certain steps that the community in Kosovo can take to be recognized in that standard. So it's now really up to your country to actually try to take those steps. Thank you. Happy to have a chat with you in the coffee break as well.
As you maybe know, Kosovo has a country code in the ISO list. It's XK. Thank you.
Do you want to
Can you please stay on the mic, or
so,
take it offline?
So yes, like I said, we can discuss this in the coffee break. XK is reserved for user identified, and it's not reserved for any specific country. But like I said, we can discuss this more over the coffee break. Thank you.
Thank you. Are there any other questions to Mirjam? Oh, Mirjam, thank you very much.
Thank you all.
Okay. So now we have a panel moderated by Vesna Manojlovic. Vesna, please. And her guests are Jennings, Daniele Bovio, Daniel Karrenberg, and Niall Oertli.
Hi, everyone. My name is Vesna. On the behalf of the program committee, I will be a moderator of this session. In the Southeastern Europe region, we have this tradition by now that we look at the history of the internet. So we had very interesting panels before, and at this time, since we are in Greece, which is a cradle of the Western civilization, it's just appropriate to continue with this historical context. And even to introduce some prehistory, because the name of this panel is how it all started. And we were also lucky to have the organization called EARN celebrate their own existence the weekend before. So then we invited them to share with us their historical insights so that we, or even more the newer generations that are only starting now, can learn from their experiences. So I will leave the panelists now to do their own talking. Thank you. No, I will sit over there.
Okay, hello everyone. I am Daniele Bovio, like Vesna said. I'm an Italian. For people that don't know me, because I'm very ancient, I am among the founders of the Italian Academic Research Network called GAR. I'm a former EARN technical manager. I was the EARN Network Operation Group chairman while it existed. I also happen to chair a RIPE working group about maps. We were trying to map the network back then. It was so small that would fit in an A4 page anyway. I am a co-author of RFC 1580, and I'm currently retired from networking. But this association, this network, started exactly 40 years ago, so we decided to have a celebration for the anniversary. So EARN means European Academic and Research Network. It started in '84, and it was the first multi-vendor computer communication network in Europe. The internet didn't exist back then, especially in Europe. So this weekend, a group of old-timers, like Vesna said, met at the hotel to share some memories, food, drinks, and to celebrate, of course. We had talks recounting our EARN, an impact on nation networking, development somewhere, professional careers, and private lives. The four of us were there 40 years ago, and here during the weekend, and we are now here to give you a short overview, basically, of where and how it all started, and a summary of the lessons we learned, the positive, the negative, the mistake we made, and to give you the opportunity to ask any question you may have about the past. Now, Dennis was supposed to start talking about the past.
The past. I was born in, is microphone working satisfactorily? Oh, I should introduce myself. Of course, I am Dennis Jennings. I'm the old man here in the room. I was born in 1945, and I like to think of things in terms of decades. And for the first decade of my life in terms of technology, the world was really interested in computing and invented the stored program computer. In the second decade of my life, the world was heavily developing operating systems and local communications for those computers. In the third decade of my life, the idea of connecting people and computers together was the topic du jour. This was where the
technology was hitting the road. The rubber was hitting the road. This was the exciting part of computing in that third decade of my life, which means from 65 to 75, there was absolute ferment of activity and papers and so on. In that decade, in 73, Vince Cerf and Bob Kahn published the TCP/IP initial paper describing the Internet idea and the Internet protocol. But in relation to the European Academic Research Network, the idea of building networks for the academic community also became the topic of interest. And there was a lot of activity in Europe. The first country to begin to do this was probably the United Kingdom, with the CERCnet, Science and Engineering Research Network, and JANET, the Joint Academic Network. But there was a lot of activity and thinking about it, which really began to take shape in the fourth decade of my life, from 30 to 40, with the developments of the things like EARN. So let me tell you a little bit about the European Academic Research Network. And to do that, I have to backtrack a little bit to a network called BitNet, because it's their network. And that was a network that was started by a man called Ira Fuchs in Princeton and Graydon Friedman in Yale, because they had learned of IBM's internal research communication network called VNet. And VNet took mainframes as the routers and took the spooling software for spooling to printers as the mechanism, and took the NJE, network job entry, as the extension of JCL, job control language, to build out of existing components a network. So what the IBM did, it was called VNet, where they got a leased line from one computer to the next. They pretended that the other computer at the end was a printer, and they sent files to it. And that computer, in turn, could connect to other computers, pretend that those other computers were printers, and send files to it. And that way, they introduced file transfer and email between mainframes. And it was an extraordinary success. There were thousands, eventually thousands of computers connected to VNet, internal to IBM. Ira Fuchs learned about this and decided, hey, that's a cool idea for the computer centers in universities in the United States to connect together. And so a shared community of computer center managers started to do this. And that was called BitNet. Tremendously successful. And that started in 1981, I think. Shortly after that, IBM became interested in sponsoring a network like this in the poor cousin area, which was Europe. And Europe was the poor cousin in terms of networking, especially for academics, because communications was controlled by those ghastly people, the PTTs, the Post, Telegraph, and Telecommunications organizations, who had a strict monopoly on communication of any kind, except voice, between organizations. And that meant that the lease lines that were needed for networking were extremely expensive. The alternative was the initial packet switched networks, which was extremely expensive. And so IBM decided to sponsor the lines to connect main computers in each country in Europe and create the equivalent of BitNet, the European Academic Research Network. And that's how it all started. And I'll let my colleagues tell you a little bit more about how that developed. Daniele.
Oh, I've got my pen.
Oh.
It's Daniel's side.
Well, the plan was actually that Niall is next, because you were supposed to talk about what we learned from this.
Oh, well,
talk about that later.
Very well. The next part of it was that we had to build, to correspond to IBM's investment in lines, we had to build a community which could actually make it into an operational network. And this took a number of things. One of the interesting things about the IBM communication software was that it was actually open source. It wasn't free open source as we would expect today. It was proprietary open source. But it meant that it was very easy for enthusiasts in running Unix machines or commercial companies, competitors of IBM, to make software that emulated the let's send it to a printer down the road, or let's send it to a computer down the road that we pretend is a printer. And so not just IBM machinery could be accommodated in this network. And this phenomenon was already happening in BitNet, so we just had to emulate it in Europe. And so we built in each country we appointed in each country a local technical coordinator to deal with the institutions, the other universities downstream of the main site where the IBM line was landing. And so we built a cooperative community to make it all happen. IBM provided resources, the community provided operational skills and procedures, and IBM even sponsored those because there was a support team at IBM's research center in Heidelberg to do that. Now, there was a lot of political pressure, on the other hand, from the CCITT? Yes. The CCITT, the Commission in Brussels, various places, that we really should have a plan to move from the IBM lines to the public packet switch network. And ERN was persuaded to move in that direction, and we had a pilot OZ networking project that I was on the implementation team for. And at a certain moment then, the European Commission decided that they would sponsor a backbone. So this backbone was to replace the IBM-sponsored lines. But the sort of administrative structures around the backbone and the relationship, the backbone was going to connect national research and education networks, and then the ERN sites in the countries would connect to the NRENs, and there were too many different administrations in the process, and it became horrible, and that didn't work. But in the meantime, we had built a community. This community had the same kind of ethos of collaboration, pragmatism that we see in RIPE today. And I think that's the moment for me to pass over to Daniel.
Okay. Well, since we have more time, I'll also talk a bit about history. The interesting thing about this get-together of people who did something 40 years ago is, of course, to swap old stories and see old friends again. And there's always a danger of actually just talking about the good old times. We did a lot of that. But what was interesting was that all of us were also thinking about the current problems and the current state of the network. And I'm going to tell in my next intervention, not this one, about that, because we have more time. Is that right, Vesna? Yes. Okay. Fine. So I'll talk also a bit about the history. My role in this, and I'm born in 1959, so I'm a youngster. The decade of the 80s was about this kind of stuff. Networking was not like a universal utility like it is now, but it was initiatives like ERN to connect IBM machines. But there were other communities as well that were separate. Like I was part of the UUCP community, which was basically a much less organized and self-funded, not so much sponsored community of Unix users, and there was Unix before Linux, of Unix users who actually did something quite similar. And the structures, then there was the high energy physics. Physicists were pioneers in networking because they had humongous amounts of data coming out of these large experiments that they needed to ship around. So not all researchers in high energy physics had to be either in CERN or Hamburg. So they had a need, and also they had funding. So there was something like HepNet. And there were others as well. And my sort of entry ticket into the EARN 40 years anniversary was not so much that I was part of EARN. I also operated an EARN node, but was that I operated some gateways between EARN and EUNet, and which is the UCP network and other networks. Because what was the killer application then, the only one that worked across all those communities, was electronic mail. And what we did there was basically application layer gateways. So we had machines that were connected. I operated one that was connected to EARN and connected to EUNet. And on the application layer, on the mail layer, basically our mailer knew how to speak to both sides. It didn't pass packets or bits directly between those networks, but on the application layer. So mail comes in, we would look actually at the envelope in the mail and say, oh, where do we send this? Is this a local user? Is this someone on EUNet or on EARN? And would send it on. And what I learned from this is that networking is about people. Because this only worked because we knew each other. We had a common goal, even across different communities. And the people who were sort of at the interconnection points where these communities interconnected could make a great deal of, have a great deal of impact on goodness for the users. And we did that just because we wanted everybody to talk to each other. It was very new. It was exciting to be able to send files and emails, files in emails to colleagues in the US, to ask questions to colleagues in Scandinavia, and to actually collaborate on writing articles and documents much more easily. We even got software updates through the network. And before that, you had to get them on magnetic tapes, which had to go through customs and took months. But what I learned from it is basically the personal relationships. You know, just walk into this other university and say, hey, I have this network. Would you like to participate? And the goodwill you get by just basically having a common goal, that was great. And what I also learned is that in times when something new is created, those are the fun times. Pioneering is really exciting and a lot of fun.
Fantastic. Now, I think it's the time to tell you the ugly truth, okay? Because there is always some skeleton. Yes. Questions?
Yeah, maybe we can open it for some questions.
Well, one thing I want to say, and then we open for the questions, okay? So basically, if you are all here today, and you are all using happily this TCP/IP protocol stacks, it's thanks to EARN. You know why? Because when EARN started, the European Commission was completely and totally against that. Why? Because it was not a European open protocol, it was an American protocol, bad for the European industry that wanted to have their own system to communicate, right? So they started all possible attempts to tell EARN, what you're doing is illegal. You have to stop. The PTT said you cannot transfer data from countries because you're not a telephone operator. We can only do that. You cannot do that. And so forth and so forth. The Commission went up to sponsor a meeting where another organization was created named RARE that was supposed to push for these OSI protocols that Niall was trying to implement. All that was an incredibly huge smoke screen. The Commission was focused on killing They forgot about IP. They had no idea about that. And then when RIPE was born, right under this umbrella. So was the lightning rod, if you want, from the Commission that allow RIPE to slowly but steadily and gradually take over until it was too late. They couldn't stop it anymore, okay? And then when that happened, there was the first pan-European IP network was created called EBON in '91, thanks to our friends of SurfNet, the Dutch academic network that came up with the ideas. The OSI thing is good, but it's too far ahead. It doesn't work now. So let's create a multi-protocol backbone where we can test X25 and IP, etc., and then we'll see. And of course, that was also a smoke screen. All we wanted was an IP backbone, right? So that started and that developed, and in, what was it, 94, pretty much, managed to migrate most of the circuits you see on this map now on the screen that were used to be kind of on synchronous, 90.6 synchronous circuits, 64, some of them, migrated to this IP backbone, thanks to one of the multiple applications of NJE that was able to turn on to IP, which was VMNet, written by Princeton University. We moved all our links over to EBON, and most of the countries also followed. And then the entire service that EARN was providing moved onto the internet, if you wish. And that's where there was no stopping it anymore. The dam was broken, and the Commission couldn't do anything anymore but say, oh, maybe this internet stuff is not so bad. Let's stop fighting it. Now, I think with this provocation, we can open the floor for the questions.
I doubt that everything's clear.
Yeah. Okay, then maybe we can talk a little bit about the bad things we did.
Well,
and the good
things that we learned.
And what we learned, right?
Yeah, what did we learn? I mean, you have to cast your mind back to the time when, as I said, there was a complete monopoly on electronic communication. It was illegal to try and do what EARN was trying to do, because that was third-party traffic. That was such an absurd position to take for a community network that eventually the CEPT and CCITT and the PTTs decided that EARN was a community network and it was only internal traffic, and it was permitted for that purpose, no other purpose. We also learned, as Niall has just indicated, that standards are important. And whether proprietary or open, that published standards that people can use are extremely important. But we did learn that premature standards, that is, standards that are promised but don't exist, are a terrible, terrible curse. And the problem with the ISO OSI standards was that they were so detailed that they took forever to develop, and that ultimately they were never delivered what the academic and research community required. They were designed around a model of telematics. Perhaps you've heard of telematics. And that was the important business model, was you sent an inquiry to a remote big computer which sent you answers. You paid for the inquiry and you paid for the answers. This was the PTT model of communications. This model didn't work at all for the academic community. On another hat, I went to in '85, went to the United States and designed the NSFnet. Was able to do that because there was actually no national network in the United States. There were lots of mission-oriented networks, because there was a lot of money associated with the supercomputer activity to build a network, and because the TCP/IP protocols were available. And that was an extraordinary success, illustrating that if you meet the needs of the users, if you use standards, but standards that exist, and if you have a telecommunications environment that's positive and supportive, you can do amazing things in a very short period of time. It took a decade for EBON to happen, to do the same thing in Europe.
In fairness, apropos EBON, this will be very short. EBON was actually received support from from Brussels, didn't it? Funding?
No.
No?
Funding.
I'm wrong.
Funding from IBM.
Oh, that was from IBM as well. No, I thought that was the beginning of the Commission beginning to see the light, but it took them longer than that.
Yeah.
Yeah.
Looking forward to a question. We also learned, of course, that governments are two-faced.
Only two? Minimum.
They have their agenda, and the Commission spent a lot of time in convincing the national research networks in the various countries that the Commission was going to do lots of good things to support the academic community. But its view of supporting the academic community was that the academic community would do what was necessary to support industry, because that was the point of the whole activity. And in my view, never once really helped the academic community build academic networks for academic purposes. So we learned a lot. Yeah, from that episode, I can say by that time I was in the Netherlands, and one thing I learned from both the EARN experience, the EUNet experience, and what happened then was there's nothing good unless you do it. And if you are in an environment that at least tolerates what you're doing, it's good both for your own initiative and for that environment. The Netherlands, now you may know that there's one of the biggest internet exchanges in Europe is in Amsterdam. And I would posit that the reason why that is not because Amsterdam is such a beautiful city, or it had very good telecommunication infrastructure at the time. It didn't, but because this initiatives for running TCP/IP internet networks and interconnecting them were tolerated. Of course, when you now ask, like the city government, the country government, they say, oh, we pushed this, we supported this, we're the great heroes, we were behind you all the time. Of course they weren't, and in other countries they were actually vehemently opposed, and they were not tolerating it. But in the Netherlands there was at least tolerance. Sort of, if you did your own thing, they didn't make it impossible, and then sort of gradually it went into, well, let's use this as an interim stopgap thing, like Dennis said earlier, and so on. So I think what I learned is, if you see something that needs doing, just do it, and find the environment where it's tolerated. I'd like to take another 30 seconds, 1 minute, to talk about what my old friends had to say about current problems, and give you a bit of maybe food for thought, because all this old stuff might not be really that interesting. It's very interesting to us. It's very interesting to us. There were two things. François Flukiger was there, and he's a great hero of stuff happening at CERN at the time, both in the networking area and in the World Wide Web area. As you may know, the World Wide Web originated from Tim Berners-Lee while he was working at CERN in Geneva. Energy physicists again, they had money. And what François found out to his surprise was when he was sort of looking around on the internet on the story that you can find about how the World Wide Web originated, is this one paragraph that says the World Wide Web was invented by Tim Berners-Lee. We all know him, or should at least, and Robert Caillot, which is kind of a half-truth, because Robert didn't invent it, but he was the best person of explaining it to everybody else. So many people learned about the World Wide Web first from Robert, so they would think he invented it, but so that's fair. And what was it, Sam Walker. Sir Sam Walker. Who has heard about Sir Sam Walker? Yeah. So François found that this was in very many places when you Googled it, that there was this paragraph that said it was Sir Tim Berners-Lee, sorry, Tim, Robert Caillot and Sir Sam Walker. And it turns out, you know, I'll make the story short, is that someone spammed Wikipedia with this paragraph. So it was digital vandalism. And Wikipedia almost immediately retracted it. But the cancer was already out there. And so François and others from CERN sort of tried to exterminate it by sending mails around and say, take this down, it's not true. Over the course of a number of years, it has always cropped up again. And that is a lesson that we should all learn, is that, you know, if some misinformation is out there once, due to the hyperlink model and the web crawlers, you cannot get rid of it. Yeah. So I found that very interesting. We didn't come up with solutions here, but everybody should have that in the back of their minds. The other thought sort of about current things came from Pantelis Tsotsakis. He's obviously Greek and a famous figure here, I understand. One of the early pioneers, but also he did lots of other things for technology here. And he basically put our attention to the fact that what you see now with information and campaigns and things like that is very much a product of big platforms knowing user behavior on all levels. And I'm not only thinking about the Googles and that tier, but also about, say, manufacturers of products like automobiles and so on, who get a lot of data about user behavior. And the question whether they should really own that data. Because if you think about it, you know, even in the political realm, in political campaigns, you know, the big platforms, social media platforms, know immediately, like within minutes, whether a particular item of information or disinformation actually gets picked up and leads its life and gets shared and things like that. So they know how actually even our societal thinking works, how our political communications work, how our, well, even group communication in very definite groups work. And there's a fundamental question is whether these platforms actually should own that kind of data. And I think we need to, and I found it very refreshing that my old colleagues who have hair color even whiter than me, and maybe some even less hair than me, are still with us and thinking about these fundamental questions. That was very, very encouraging.
It's not, though, a new question. Plato once did a Gedanken experiment, a thought experiment, and he postulated that he asked the question, what would the unobserved man do? How would the unobserved man behave if he was truly unobserved? And having reflected on this, he concluded that the unobserved man would behave badly. We now have billions of unobserved people connected to this networking that we're so proud of. And believe it or not, we've discovered that the unobserved man, or indeed woman, behaves badly. And this is probably the most important question for society right now. I don't know if you know about RTB, real-time bidding. Hands up who know about real-time bidding? Very few of you. Real-time bidding is the system that allows people to find out who you are, look up who you are, advertise, auction an advertising space, auction the space, and put the advertisement on your web browsers in the second that it takes to scroll down. That is based on a database of culled information, extracted information about you. There are billions of records about you. Well, not about you, but there are billions of records about billions of people like you. And they cover every potential aspect of you. The way you think, the way you act, the way you perform, your sexual proclivities, your religious activities, your social activities. And that information is coordinated by a set of standards, which are promulgated by a couple of organizations, one of which is Google. And that information goes to data brokers and is sold across the globe, including to the Russians and the Chinese and the Americans and so on. This is an appalling vista that is actually a reality. And it's one of the consequences that we did not anticipate when we quite happily created communities and networking for those communities.
Correct. We are responsible, but we didn't know about it.
It's all your fault.
We didn't know about it. And just one last about what Daniel said. These things, this process is happening faster and faster. So kind of is an exponential growth. So we are basically being fed our own shit, okay? That's the way it is. So I think, Vesna, you can take over for the questions now.
Since I don't see any other people running to ask questions, I have one. I was surprised when Daniel said that the email was a killer app. So to me, that sounds like a parallel to what is happening now with all these walled gardens where people are exchanging messages, but they cannot actually communicate between the walled gardens, just like your networks, which were running on different protocols, needed these gateways, and then the email was at that time the killer app. What kind of parallel can you make based on your experience about the current situation, or maybe the future situations? What could we work on? What could we expect? Something, questions based on your comment that the email was a killer app at that time. Thank you.
Okay, I'll start. I think there's lots of things you can think about here. Yes, email was the killer app because that was the only universal one. And that's also why there were lots of people working unselfishly on this interconnection. Yeah. But you have to understand, sort of from the technical perspective, this does not scale. You cannot, once the user populations get so big and the volumes get very big, do things through gateways. So I don't think gateways are the panacea here. They worked then because the lines were so slow, and the population, the internet population, was so small. The files were so small. And the files were so small as well. Yes. About the walled garden situation, it's basically not so much the garden walls, but the critical mass. I have tried to educate, for instance, my children about informational self-disposition and do not hand off information about yourself unnecessarily. But and in the beginning I had some successes, but with the advent of WhatsApp, I lost. Why did I lose? Because all their friends were on WhatsApp. And when I said, well, yeah, but you sell your behavior to a very big platform, and also at the time there was no end-to-end encryption in WhatsApp and things like that. And said, there's better alternatives. And they say, yes, Dad, we understand that the alternatives are better, but our friends are on WhatsApp. And I said, well, then recruit your friends to these other things. And they said, no, the barrier is too high. So what we have right now is wherever a big number of people congregate, there's power. There's and that is something that I have to say personally I did not anticipate. I thought universal communication would be universally good. Well, I can remember that we all sort of worked towards it, right?
Yes, we did.
Yes. So sorry, Vesna, I don't have a solution, but being aware of the problem is maybe a first step towards a solution.
Remco?
Hi, Remco. Speaking as an individual, I guess. So here's a little challenge for the esteemed people right in front of me who've been at the base of all of this, because I think we have any number of interesting challenges, but the one I want to throw in front of you is one of application level interoperability. This is very complicated language for at least the ITU got one thing right, is if I pick up a phone and call someone at the other side of the world, their phone will ring and I will be able to have a conversation with them, irrespective of what network they are on. And with these walled gardens that we've built on the internet, whether, I was doing calls this morning again, and we have the wonderful world of, well, IP telephony or video calls, where everyone is using a different platform, and once you're forced to being used to use someone else's platform, you're stuck in a hellhole of having to update applications for hours on end, and in the end stuff still doesn't work, and half the meeting is about, can you hear me now? So really, with all of the interconnectivity that we've done, it's a little bit like on the technology side, creating power is typically still done by boiling water, irrespective of what kind of technology you use for doing so. What we have is an internet right now, which essentially has some open platforms like email and IRC, some somewhat open platforms like HTTP. I'm hesitating to call it open these days. And a whole sort of proprietary takes on, well, basically those three. How do we work our way out of that again?
I'd like to jump in here wearing the hat that I wear because of the role that Mirjam introduced me as. And the thing is, back whenever, today I'm the vice chair of RIPE. I learned of RIPE while I was working on this OSI project and got sucked into RIPE. And it's been great. But the thing is, back then we thought, if you like to say naive techies that we were building a common good. And what we see today is the plutocratic usurpation of that common good. And that's an effect of scale. As long as we were building a small network with a few thousand nodes for a small academic and research community, originally discipline specific or operating system specific, but as EARN developed, it became open to philosophy departments, history departments, and not just computer science and physics departments. So we thought we were building a common good. We think we succeeded in building a common good, but once the infrastructure that we had built grew to a scale that it could support this kind of plutocratic usurpation, and some of you may know of a Canadian pundit who has a much more colorful phrase for this. You can laugh at it if you like, but I prefer the more elegant one, especially since we're in Greece and the etymology of plutocracy is a Greek one. We this problem, I think, can only be addressed by people outside the technical community, bringing other professional approaches to it. And I was in a room with some of them this morning in the RIPE-NCC roundtable with regulators and those kind of people that we techies have to learn to trust. And we have to, I think, for me at least, I identify the problem. And here I'm not trying to represent the community. My personal view is that here we have market shaping, market regulation necessary, consumer protection regulation necessary, and these are the approaches that have to be taken to solving the problems that have been brought about by the walled gardens, which exist only in order to funnel riches to people who are already rich.
Yes, hello. Desiree Milosevic, co-chair of the Cooperation Working Group. I really appreciate this discussion and having these hindsight things. Oh my God, what did we do wrong? And we could have more of these discussions even at the Cooperation Working Group. But I also think there's this myth: if we only do this, everything is going to be fine. And it's, I think that's the biggest myth that we have. But one thing that I wanted to ask about, actually maybe two things. One is recently I've seen this very interesting article called Rewilding the Internet, how when we try to simplify very complex systems, we tend to mainstream them and we kill all this diversity in the system. So I'll welcome some of your thoughts, what you think about that, with consolidation and everything else happening in the market. And the second one, I just like to point to this global initiative on digital empowerment that I'm part of, that are looking to create new avenues for personal data to be used just for people and possibly make money. Is this a social utopia?
I don't know about social utopias, but one of the things I think we missed in the early days was the fact that we did regulate ourselves. We the community, built networks for the community, and one of the byproducts is we did regulate ourselves, and we devoted resources at no cost to contribute to the community, like gateways for mail and so on. We did anticipate that the network would become a universal activity. Its power was so obvious. What we didn't understand is that there needed to be regulation, particularly in the dot-com boom area, where information has to be free. Idealism was the idea du jour, and it corrupted the thinking about networking and the regulation of networking. All human activity, if it is to be socially acceptable at any level, needs some power of regulation. And that has been usurped by these global monopolies, pseudo-monopolies, these large platforms. And until we find a way of accepting that there needs to be regulation, and for the technical community, informing that regulation so it isn't stupid, and that's a really important point. We are going to continue to have these large platforms whose only goal in life is to addict us to whatever their product is, enslave us and make money. And we're seeing that on oil, we're seeing that on cigarettes, or smoking, now vaping, we're seeing it on food, with ultra-processed food. The whole world has gone to a mindset that says, we will create monopolies, we'll create products that are addictive, like referral systems on social media, and we'll make lots and lots of money, and we will be so powerful, we'll be larger than most economies, and then nobody can stop us. That's the challenge for society, not just the networking people, society to address now. And the role of the technical community, as I said, is to make sure that the regulators don't do stupid stuff.
Here, here. And answering, if I may, just to Remco, the question of application interoperability, I think that hasn't succeeded. We have standards for interpersonal messages. Still, we have WhatsApp Signal, Telegram, la la la. We don't have standards for sort of social media platforms, but yeah, one could have that. But where is the incentive? Where is the incentive for those people who want to enslave us to be interoperable with the other people who want to enslave us? Yeah, I think Dennis is absolutely right. We have, as societies, we have to come to the conclusion that they don't own us, and we should unown them. To say it very succinctly.
If I may interject there, and sorry for interrupting the next question. One of the suggestions on platform interoperability was to enforce it. Now, the last thing I want is to have my social media, not that I'm on social media, I think it's all crap and I don't use it, but if I were, that all the other crap from all the other platforms would be enforced onto me through interoperability. So if you want to have interoperability, it would have to be at the user's discretion.
Opt-in interoperability.
Opt-in interoperability. Sorry, I'm sorry for taking the time.
Question.
First of all, I think I'm the youngest person in this room. I'm 22. I feel very lucky to be here, actually. I have very beautiful people in front of me. This is not a question. I didn't come up to ask a question, but rather talk about this Sir Sam Walker mystery. So yesterday I talked with Francois about this, a little chat. So I took some notes on what happened and what have I just done 1 hour ago. So first I'd like to say misinformation on the internet, once it's put on the internet, really, you can't make it disappear. So once it's out there, it's there. So the Sir Sam Walker wiki page.
Whether it's true or not, it's irrevocably out there.
Exactly. So the Sir Sam Walker wiki page was deleted in 2007. And after that, I believe there was no mention of this person whatsoever on the internet. That's just an opinion anyway. In 2010, so this name pops up again on a website, and then at least 3 academic papers include this name and cited that website. So
I didn't say that because it was just too painful to admit.
So yeah, well that said, just recently I submitted a page. Actually, I revived the Wikipedia page, not yet. I submitted a draft, and this time it doesn't give you misinformation, but rather it addresses it. So. So yeah, I think the best thing we could do was to address the misinformation, at least have it on Wikipedia. So once someone comes up on the Google, searches up who's this Sir Sam Walker person, and now they see this Wikipedia page of this person, and the Wikipedia page says this person does not exist, is fake, and it also cites the academic paper, so a few people also get ashamed, maybe.
That's actually a terrific idea. Instead of just trying to delete it and kill the cancer, just put the anti-cancer beside it.
Exactly.
So it should self-destruct it with time.
So
Maybe
yeah.
you find the antidote. Who knows?
Well, it's still a draft, so some Wikipedia maintainer must approve it. So maybe if a lot of people here agree with me, that may be an incentive for them to approve the page to go live. So that's it. Thank you.
Thank you.
Before you sit down, what is it we need to do to help your initiative?
I'm not quite sure. I mean, this This was actually my first time submitting a page to Wikipedia. It was kind of like a just idea we had with Francois talking yesterday. So I have no idea. Maybe this is being live streamed or somehow some Wikipedia people will see it.
So if someone here knows how to deal with Wikipedia, talk to this man.
That would be brilliant. Thank you very much.
And then we will let you know after the coffee break what you have to do. Thank you, Vesna.
Thank you to all the speakers. We have 2 more minutes, so you have 30 seconds if you want to have a closing word, and otherwise, last questions, or we go and have a coffee a bit earlier.
Coffee! Well, we can tell a joke if you want. I mean, just...
No, it's... when I was thinking about Remco's question and Daniel, your response, I thought that remember Leslie invented the word permissionless innovation. What did that bring us?
I'd like to address that. Permissionless innovation is a lovely idea. Today, I believe it's a myth. It's a nice aspiration, but it's no longer available to the internauts of today, unless you're part of an elite which can somehow avoid, if you're something of the scale of Internet 2 or in Europe, Géant, you may be able to push ahead in the protected environment, the protected development environment there, where there is still permissionless innovation preserved. But for the rest of us doing hobbyist computing in our homes or small, micro enterprises, permissionless innovation has evaporated. I don't know what we can do to seize it back again, but that's my, with apologies for the pessimism, view on permissionless innovation today.
Can you finish on a positive note, or shall I?
Dennis is going to.
Yes?
Okay. Hands up in the audience, who as part of your professional training has had a course in ethics? Yeah, not that many of you. The behavior that's within these hyper large platforms is extraordinarily unethical. The latest wave of enthusiasm for generic machine learning, AI, so-called ChatGPT and so on, based on scouring the world for, without permission, personal information, copyright information, incorrect information, and maybe some correct information, is a gross violation of humanity, in my view.
Here, here.
And it could not have taken place without a complete lack of any ethical understanding among the technical community. Just because you're smart and you can see the door and you know how to open the door, and through that door you can see the keys of the car on the hall table, does not give you permission to go through that door and take the keys and drive away the car. It is still theft. And that's not really understood, as far as I can see, among the vast number of people who are involved in the commercial technology industry. And we need to bring back that thinking.
Okay, I think we are closing, so Vesna takes it over. I just wanted to say, don't hesitate to come during the coffee break and ask further questions to any of us. We will be there.
Thank you very much for the speakers. Thank you.
Hello, everybody. Good afternoon. Hope you had a nice coffee break. So let's get on with the program. Let me introduce Georgi Nolis, who will talk about why Greece is the new telecoms gateway. Georgi. Okay. Sorry.
All for coming to this presentation. As you probably have seen, The title is Unlocking Greece, and we will try to answer the question, why Greece is the new telecoms gateway? Gateway to where? Gateway to Europe. This one word missing here, that I left it on purpose. So let's have a look about what is happening right now. What kind of infrastructure exists, what kind of cables we have, and let's see where Greece is positioned. We see here the whole Europe, and right at the edge is this relatively small country. But being at the edge sometimes can be a disadvantage, and sometimes it can become a very important advantage. So you will probably notice that there are some physical cables that are coming, and they are land-based from Albania, from North Macedonia, from Bulgaria mostly, and some also from Turkey. And there are some brand new submarine systems that have been introduced the last year, so they are very new. One is the TAP, Trans-Adriatic Pipe, which is the gas pipe, and the other one is the Ionian cable. Both of them were inaugurated in 2023. So, right now, Italy, it's the first time in history that is closer to Greece than ever. You all remember, I presume, the old cables like Nautilus, which were doing a very big round through Crete and going after to Athens and so on. These cables are straightforward, going directly to mainland of Greece. And this also creates, let's say, a crossroad between north, south, west and east. And the crossroad, if you can see a cross here, is Thessaloniki. Thessaloniki is a better position in terms of becoming a hub, because if you check also the latency, from Thessaloniki to Sofia, it's 5 milliseconds. From Thessaloniki to Athens is 6 milliseconds. I'm talking about round trip here. Also, Thessaloniki to Italy, it's less than 4 right now. And if you go north, of course, it goes more. And Thessaloniki to Crete, and I will get back to Crete, is around 9 to 10 milliseconds. I've been an engineer all my life. Even as a young kid, I was breaking toys in order to understand how things work. And I think that I'm talking to engineers as well here. So the engineer is someone who always thinks of a better way, thinks how to solve problems, thinks how to, let's say, do something that wasn't existing in the past. So, as I said in my previous, let's say, introduction, sometimes the obvious is not very obvious, and you need to rethink about it. So, going to Google Maps and using this measure distance tool, if you choose one edge to be the Suez Canal, and let's say the other edge to be Frankfurt, for instance, you will see that this straight line actually passes through Greece. So, okay, that looks interesting, because we all know what Frankfurt is for Europe. We all know about DECIX, we all know about all the networks that exist there. And we also know what Suez is doing, since more than 99% of the connections between continents, it's being transported through submarine cables. This means that actually all the submarine cables that are passing from Asia, from Middle East, from Australia, or whenever you want to call it, are forced to pass through Suez. The other way is around Africa. It doesn't make sense. So let's say that we cannot avoid Suez, we all know that, and now we want to address to whatever you want to call it, Frankfurt, or maybe you want Amsterdam. Isn't that a very important place where AM6 is, for instance? We were talking about AM6, the previous guys, how things started. So, still this straight line passes through Greece. Even if we say London, which is also a very important place, still passes through Greece. So, what is a straight line? You remember, I presume, that it's the shortest distance between 2 points. And since we are talking about physics, meaning that the fiber can actually use photons to make all these interconnections, choosing the straight line is by far the best choice, having the lowest latency, because otherwise, if you go through Marseille, for instance, the latency goes way higher. So, Steve Jobs used to say one thing here, one of the many things that he used to say, is it doesn't make sense to hire smart people and tell them what to do. We hire smart people to tell us what to do. So you are here as engineers, you are here as business owners in order to make some decisions. So obviously, I will not tell you what to do. You will discover it yourself. So let's have a zoom here about what is happening to Greece right now. We have all these fibers that we've been talking about, but we also have here some things that we have prepared for these fibers. The first thing that we have prepared is a very big investment in Thessaloniki. Obviously, Thessaloniki was the first place that we have to do this, and we called it Balkan Gate. It's not a matter of luck that we call this data center, this first tier 3 carrier neutral data center, Balkan Gate, because we want all the carriers to come to Thessaloniki. It is inevitable if you see this cross that I was talking to you about. So the crossroad is Thessaloniki. Even historically, Thessaloniki was the main road, Egnatia, that was connecting Istanbul to Italy. And this road exists up to today. It's the road that if you want to travel to Istanbul, you will use Egnatia Road. If you want to travel to the other side of the country, you will still use Egnatia. But that was not enough, because many times networks were coming to us and they said, yes, we want to come to Greece, but it's very far. We cannot interconnect with you, so what do? And for this reason, we did another thing. We went and installed some POPs. Obviously, in Sofia, it was the closest and made sense. So we went to Telepoint with the WDM 100 gig, and then, obviously, to Frankfurt, where Equinix FR5 seemed to be the carrier hotel, the most important or the most well-connected, let's say, data center, and then obviously to Nijmegen in Amsterdam, and then obviously to Mix in Milan, and of course to Sineca Cisar, to Namex, and then back to Greece. Why we did that? Because we would like everyone that wants to have a taste or wants to get closer to Greece to use all these interconnections and come. And of course, some other people start doing some other investments, like Andromeda, like Medusa, like India-Europe Express, like to Africa. You remember to Africa in the beginning, it was not supposed to land in Crete. The initial plans were actually skipping Crete, just like most of the cables. But obviously, some things changed, because I had a discussion outside with some gentlemen, and they asked me, why is this happening to Greece right now? Of course, they are happening for many reasons. One reason is that Greece is very stable politically. The other reason is that Greece has a completely different mentality, and is actually supporting all the investments that are being done in the soil of Greece. So that's the reason why the 3 OTTs that I've mentioned in the beginning of my introduction decided to invest in Athens. They didn't decide to invest in any other territory. They could go, for instance, in Bulgaria, where all the networks are right now, or probably in Turkey, where the eyeballs are. But that's not the case. Most of the service that we get, for instance, from Microsoft Azure right now, Office 365, are coming from Ireland, not even Frankfurt. So if you consider the radius from Athens to Ireland, and you see this radius going on the south, you will understand that from Athens, which is the furthest extension of Europe, all the OTTs can actually serve these territories that are called Middle East, North Africa, and in general, Eastern Mediterranean. On top of all the things that we have done, we realized that we should also establish a second internet exchange in Greece. And we did this with NETIX. NETIX Greece is something that we believe will help the current situation of exchanging traffic in this country, because there's going to be a lot of traffic, obviously. And you do understand that all these massive data centers that are under construction as we speak are going to generate a huge amount of content. So all this content is going to be distributed between Thessaloniki, Athens, and Heraklion. So this is the first exchange in Greece that has a mesh multi-100 gig network that interconnects all these major points of concentration of traffic. On the north, Thessaloniki, in the center, Athens, and in the south, Heraklion. This is an overview of what is done right now. Heraklion is still under construction. It is expected to be ready in service beginning of 2025. And these are some interconnections that we already have to go to the rest of Europe. I hope that it was quite fast. I didn't want to bother you with many details, but I'm available for any questions that you may have, and I will be more than happy to answer them to you.
Osama Dosri, I'm from the MENOG region. I'm also part of the Saudi Internet Exchange. Speaking on my own behalf, just a question. The connectivity, the mesh between the different exchange points, how is it being funded, or what is the funding model for it?
We are self-funding those interconnections. Lancom has heavily invested in DWDM systems in the country, and also in high-end network equipment from vendors. So everything is funded by Lancom.
So the exchange points themselves are Lancom's?
Yes, yes. This is NETIX Greece, not NETIX Bulgaria, for instance. So it was named NETIX because we prefer to use a brand name that has some awareness. It could be named Lancom Exchange, for instance.
So it's not, the NETIX is not an association for the local operators, it's rather for international connectivity. Is that
yes, NETIX is for international, and NETIX Greece is only national, only Athens, Thessaloniki, and Heraklion. And it belongs to Lancom 100%.
Thank you.
You're welcome.
Do we have any more questions? No. Thank you, George, for the presentation.
Thank you so much.
Next up, we have Ivan Pepelnjak with a presentation about joys, lots of joys about virtual networking. Thank you, Ivan.
should I say Kalimera or Kalispera? Someone will, Kalispera. Yeah, thank you. How does this work? Okay, that's me, and based on the roundtable we just had, I forgot to add that I was running the UUCP node in Slovenia in, what was it, late 1980s. And then I started doing things like tearing apart SDN and OpenFlow and all that, and that was great fun. But, you know, I got bored by that. I also built too many labs for one lifetime. I invented a virtual lab system like 3 times at least. First on gear that we were accessing over ISDN, and then gear that was accessed over the internet, and now it's totally virtual. And I hate building labs. I can't tell you how I hate building labs. Which brings me to a real-life story. I got this question from someone on September 1st last year on my blog, when I was blogging about OSPF unnumbered, and he was like, gee, I wonder what would happen when you have parallel links. And well, the obvious response is, dude, did you consider labbing it? Because that would answer the question in like 30 seconds. You wouldn't even have to write a comment on my blog, but thank you anyway. And then I realized, oh shit, someone has to build that lab. And not everyone is as lucky as I am that I have the infrastructure to do it. So you know what happens when you try to build your lab. You start with something like this. Obviously, unless you are a consulting architect, in which case PowerPoint is your tool. Anyway, these were the labs we built and hated to build. And imagine you would have to redo that topology in this lab with all these cables. Luckily, probably 20 years ago, someone figured out that you could emulate the MIPS processor in the that Cisco was using on their routers, and wrote an emulation where you could run Cisco code on x86, and obviously it was illegal as hell. And later, Cisco came out with this product. This is a this is a viral screenshot. And now we have GNS3 and all those things. And you know what I hate about those things? They're all GUI-based. My wrist is hurting. And you click your way around this, and you build this topology. And then you think, now I'm done, now I can answer this question. And no, you're not done. Because you're just at the first step. Someone has to create the addressing plan, someone has to type in the IP addresses, someone has to type in the initial configurations for all the devices, someone has to create maybe virtual interfaces, someone has to configure OSPF, and then I can do show IP route and see what the result is. By that time, I'm in this stage. But now, let's talk unicorns. You really don't want to deal with that, right? What you want to deal is something where you can define your lab on a high level. Like, oh, I have 2 nodes. And by the way, this is YAML, so you know how to write that if you ever had to write an Ansible playbook. And if you did, I'm sorry. Let's make them Arista containers. So I will use the Arista as the default device. I will use Container Lab as the provider, which runs Docker underneath. Oh, they're running OSPF. So I have this 15 different modules that you can turn on. Well, I'll use OSPF. We need 4 links. We need R1 connected to nowhere. We need R2 connected to nowhere. And then I need 2 links between R1 and R2. And oh, by the way, they are unnumbered. So I have this parameter. Well, you have to know what to do. On point-to-point addresses, I want to use IPv4, but I will not specify the prefix to use. I will just say true, which means unnumbered. And then you execute a command called netlab up, and magic happens. Now let's see if the magic will happen. Good. So you start that, it creates the configuration files for Container Lab and Ansible, and then I had to type in my sudo password. Now Container Lab is spinning up the containers. This is real time, by the way. And now we are waiting for Arista to start. It's recorded, it's not in my lab. Arista is slow to start, FRR would be faster, but we're done now. And now Ansible started and is deploying the initial configuration, and now it's deploying the configuration on the devices. Yet again, Arista, speed up. OSPF is now being deployed. This is real time, real speed, and now we're done. The lab is up and running. Now I can connect to one of the boxes, and I have to wait the mandatory 40 seconds for OSPF to do its magic. And now I can do show IP route OSPF, and I have the answer. It took me what? A minute to write the topology, 30 seconds to start up, 40 seconds for OSPF to figure out that, oh, I'm OSPF, I have my neighbors, gee, let's do it. And then I have the answer. So this is what happened behind the scenes. In the last 3 years, a number of us wrote an open source, free, totally free, orchestration tool that takes your topology file, that takes some defaults, some CLI arguments, modifies that into a data model that is then used to configure individual devices. And then we wrote tons of configuration templates. So you have this OSPF data model, and then you have a template how to configure OSPF on Cisco iOS, iOS XR, iOS XE, Nexus OS, Arista, the list goes on. We use Ansible to deploy that. As much as I hate Ansible with passion, it's the only thing that can deploy configs on 50 different platforms without me investing in code. And I love using things that other people developed. So we use Ansible. And in the middle, you have this start the lab thingy and orchestrator configuration, because we don't want to reinvent the wheel. There are people who are orchestrating virtual machines. One of them is Vagrant. The other one is Container Lab. So we use those. So just the umbrella on top of that, plus all the configuration templates. And what that brings you is a fully functioning lab. And then you can start playing with the interesting part instead of wasting your life typing in IP addresses and BGP neighbors. So the initial use case was just create the Vagrant file, because if anyone has ever tried to create a Vagrant file for a virtual lab, I feel really sorry for you. That thing is a mess. I did it once, and then I started writing this software. And then, when we have the links in the nodes, it's obvious that we can add addresses. So we created the address pools for IPv4 and IPv6, for LAN, for point-to-point links, for VLANs, for whatever. A few weeks ago, I added DHCP-v4 and DHCP-v6, because why not? Then we have the initial configuration template for like 20 different platforms. Then we can create the VLANs, the VRFs, the VXLAN tunnels, generic tunnels if you wish. And then you can choose 4 different routing protocols, plus MPLS, plus MPLS VPN, plus 6PE, plus EVPN. Anything else you want? Please submit a pull request. We are accepting contributions. Obviously, every lab is special, and everyone wants to have their own special things, so we added tons of extensibility, like you can add your own configuration templates. You don't like how we build device configuration, like a friend of mine saying, you do Juno's configuration wrong. I'm like, dude, fix it. You don't want to submit the change? You can still fix it on your own, and the system will use your own modifications, but, you know, whatever. Sometimes people want to do more. So we have this plugin system where there are like 15 different hooks that are called throughout the data transformation phases. And you can do anything you want in there. You can write your totally own IP address manager if you wish. I wouldn't, but some people want to. Or I implemented IP Anycast with that. Or we implemented tons of BGP nerd knobs, like allow AS in or AS override or all that. This is the current level of support, covering all major vendors, plus a few interesting Linux control plane software. If anyone has any idea what else we could support, let me know, because I'm running out of ideas. No, just don't mention Sonic, please. We work with KVM, with libvirt, and theoretically you could use libvirt and work with, I don't know, VMware or whatever other virtualization system. Never tested, KVM is tested. Container Lab gives us access to Docker. Supposedly they can work with Podman. We didn't test Podman, we do test Container Lab. If you want to have hardware lab controlled by this, it can be done. But then you have to enter in the interface names, because I don't know how your interfaces are named. We were working with VirtualBox because people wanted to run this thing directly on their Mac or Windows machines. It's still there, we just don't test it anymore. And you can combine containers and virtual machines in the same lab. So for example, you would have a Cisco IOS XR, which has to be a virtual machine. And you want to have an Arista next to it, but I would use a container because it's fastest to start up. And then you want to have some Linux boxes. Sure, you would use containers for that. You want to connect this to your external devices? Sure. We can bridge the individual interfaces to the outside world, or we can bridge the whole networks to the outside world. It's not just me. There are like 10 people committing to this, but 2 of them are my heroes. Stefano did Aruba, Junos, DelOS, Microtik, 2 versions of Microtik, 6 and 7, and Vios. And he's this crazy guy, doesn't tell anyone what he's doing on, but all of a sudden I get this pull request for a totally new platform. Not just that, he implements 10 different modules in that platform. Like, boom, and we have a new one. And I don't know how to pronounce his name. Any Dutch in here who can help me with the name? Remco? Huh? Thank you. He did all the Nokia stuff. He's working for Nokia. And he did a lot of FR routing stuff. So he's the reason we have EVPN and VRFs and VLANs and all that on FR routing containers. Addressing, we have everything you want, plus everything else, plus everything anyone ever asked for, plus a few things no one ever asked for. On the data plane, it's VLANs, VRFs, VXLAN with static ingress replication or EVPN, no multicast. If anyone feels like they need multicast, please submit a pull request. MPLS, sure, including segment routing with MPLS. SRv6 if you want to play with that beast, it's there. Plus generic tunnel interfaces. OSPF v2, v3, so all the routing stuff, all the MPLS control plane. Someone did extensions for MPLS traffic engineering. It never became part of the course, but it's still lying somewhere. And then L3 VPN and 6PE and EVPN. And how do you pronounce that guy's name? Jeroen? Okay, close, I hope. He's real fan of EVPN, so he pushed me to do all the EVPN stuff. Bridging, VLAN bundles, asymmetric IRB, symmetric IRB, eBGP only, IBGP over eBGP, all the crazy stuff that the vendors are pushing. It's all in there. This is straight from documentation. You see that many platforms support many things. Obviously, you should go to the web and check what's actual, because this is changing, and it's changing usually in the direction of green check marks and not red crosses. There's more. For virtual machines, you can connect the virtual machine directly to a MAC VTAP interface, which is another MAC address on the Linux Ethernet port, so you can connect your virtual machine straight to the outside world. For the containers, it's done through Mac VLAN because, you know, why should 2 open source softwares use the same driver on a Linux box? That makes no sense, right? We can also do port forwarding. So if you want to connect to your lab from somewhere else, you can just open the SSH ports to the outside world, and we do port forwarding for VMs and containers. You can connect external network management tools. So they are containers that are started and connected to the management network. And then they can access all the other devices, and we even create a configuration for those tools. Then I wanted to build some labs with that, and I wanted to have, you know, the addressing scheme and the wiring scheme and BGP neighbors, so I created tons of reports. You can have them in Markdown or text or HTML format, so you have something to show to your boss. Graphs, yet again, open source is great. You need a graphing tool, you can find 3 of them, and they're incompatible. So we just wrote the code that generates the graph description for 2 of them, and then you use that tool and create the graphs. Someone created GUI for Container Lab, and because that GUI takes JSON file as the input, Stefano reverse engineered the format of the JSON file. And now we create that same JSON file in NetLab, and so you got GUI. I added automated validation a few months ago, so you can run tests. You can execute commands on the devices, and if your device is smart enough to produce JSON or XML, you can parse that and then do some Pythonic expressions to figure out whether things are working as they should. Someone asked for multiple instances on the same server, like you can use that for training. Sure, no problem, we can do that now. Someone asked whether he can restore previous configurations, and I was like, that should be relatively easy. So I just added that to one of the recent releases. Someone said, I want to run big topologies, and if I start my big topology, all the virtual machines crash because, you know, they take too long to start. I said, no problem, we'll start them in batches, and you can specify the batch size. So if you're running iOS XR, I recommend a batch size of 0 or 1. But for other things, batch size of 5 is usually appropriate. And then, well, I figure out that sometimes, you know, all the core links have the same attributes, and I'm really lazy at writing the same 5 things 10 times. So I edit link groups, which is like a macro, where you say, oh, I want all these links to have these attributes, and by the way, these are the links I want to have these attributes, and bam, it happened. Just a few examples. This is the graph that D2 software created based on the description of the graph created by NetLab. It looks cool, right? It's a leaf and spine fabric. All these graphing softwares, by the way, have a real problem positioning things so that the graph looks nice. And there's nothing I can do about that because I will not go into that problem. People were doing PhDs on that and they didn't get anywhere. So if you find a better graphing tool, send me a pointer and we might do the graph description file for that graphing tool. This is an example addressing report on BGPS numbers and BGP neighbors. And this is the graphite GUI. When you click on a node, you see that it says you can SSH to that node. So you start the web server on your Linux server. NetLab gives you the URL to use. You click on that, you get this. And then you can click on this, and Graphite provides web to SSH proxy, which means that you can access your lab, even if it's in the cloud, through the web interface. And this is the network validation part, where I defined a few tests. And these tests actually executed show commands on FR routing, because FR routing can produce JSON. And then I would evaluate the results, and, well, it says, yeah, GE, your lab works. Good job. OK. I hope you're all hyped up and you want to deploy this. Let's see how you can deploy this stuff. How many of you are running Ubuntu on your laptops? Hands up. Good job. You're all set. So if you're already running Ubuntu, you just install, well, you have Python already. You install one Python package, and that Python package comes with the installation scripts for Ubuntu for KVM, libvirt, Vagrant, Docker, Container Lab. You run those installation scripts, you're almost in business. Everyone else, I'm sorry. The best way for everyone else to start using this, including if you happen to prefer Fedora over Ubuntu, because I'm not going to support Fedora, I have other things to do, is you run a Ubuntu VM. The only trick here is that if you want to run the virtual machines in your lab, like Cisco iOS or Junos or iOS XR or whatever else, but a few exceptions, then you have to turn on nested virtualization, which is available in KVM if you are of Linux persuasion. It is available in Hyper-V. It is available with VirtualBox, and it might work on some processors. It supposedly works great on AMD, and my old MacBook Pro with Intel CPU didn't perform exactly stellarly. I still have VMware Workstation or Fusion on the slide, although I don't know what will happen with those things now that Broadcom is in the milk and cow mode. I would use Vagrant to start the VM. I wouldn't start the VM by hand because that simplifies the operations. And alternatively, if you hate all this, you can always run the whole thing in the cloud. If you're OK with containers, then you can just start a VM and it all works. Which brings me to the unfortunate people with new Apple laptops. You can actually start a Ubuntu VM on Apple with ARM CPU, and FR routing publishes ARM containers. So you can run FR routing containers on Apple Silicon, which is good enough, for example, to practice BGP. Now for the unpleasant stuff. Thank you, vendors. You're making our life miserable, and we are paying you for the privilege. FR routing is automatically downloadable, as is Cumulus Linux, Nokia SR Linux, and BIOS. Great job, guys. Thank you. I love you. Juniper finally managed to persuade their legal team that it's perfectly OK for people to download stuff without registration. So VPTX is downloadable, no strings attached. We're getting to the next step. We're not done yet. Most everything else. Arista EOS is downloadable, but you need to register. Cisco Nexus OS is downloadable, but you need to register. CSR, you need a support contract. For some other stuff, you have to bag your SE. And maybe you will get a license. They will want to take, you know, all your contact details and your shoe size and your mother's maiden name and all that. Sometimes, the VM is only available if you happen to know the right person in the development. But we're not done yet. Because if you are using containers, that's OK. You unpack the container, you install it, bam, done. The virtual machines all boot off a virtual disk. And the virtual machines that are network devices boot up with no configuration and expect communication on the serial port starting with username and password. Oh, no. First, you have to abort the boot process, which is total crap. What we need is a VM that would start with some initial configuration, and then it would, you know, we would log into it and configure it. Vagrant provides that. It's called Vagrant Boxes. But you need to build the boxes because the vendors are not providing them. So I got this feeling like car by IKEA. So if you want to get started, get some decent hardware. I'm running small labs on my laptop. At home, I have an Intel NUC with 64 gig of RAM and 16 CPU cores. So get some existing x86 hardware, better than ARM CPU with FRR containers. I would use, if you're serious about this, some standalone Linux server. For me, Intel NUC was great. They stopped doing it. Or you could run containers, which would be Arista, Cumulus, or FR routing, or Nokia SR Linux, anywhere in the cloud. And some cloud providers even offer nested virtualization, like Google Cloud or DigitalOcean, so you can run VMs in those cloud VMs. Installation? Theoretically, this thing should work everywhere, but I would start with a fresh Ubuntu VM. If you start with a fresh Ubuntu VM, we might be able to help you. If you start with anything else, don't call us. Then you install that one Python package. You run the installation scripts. They're provided for Ubuntu and nothing else because we have better things to do with our lives. Then you download the Vagrant boxes or containers. We do provide recipe for almost all supported platforms. And then it should work. On other Linux distros, everything should work. But I just got like 5 different emails from someone kind enough to telling me what doesn't work on Alma Linux because Alma Linux is a bit different. So I'll put that in documentation, don't worry, but you know, we won't be able to help you. If you're a Linux guru, please do this on whatever crazy distro you believe in and send me the patches. Is it worth it? Yeah, people are saying it's worth it. That's not, I didn't make this up. I just took a snapshot of a LinkedIn comment and a Twitter post. And this is what someone built with netlab.
Is that a rocket?
It's a crane. 50 routers from 4 different vendors running 3 different routing protocols, plus I don't know what else. 50 Linux hosts for the endpoints. And the whole thing is starting for an hour, but then it works. How can you help? Well, spread the word. Even if you don't believe in this, spread the word. Use it to build your labs, ask questions, report bugs. You want to fix the documentation? Please do so. It's all on GitHub. It's all open source. Go there, pull down the repository, make the changes, submit a pull request. We're done. You can fix bugs. You can also add functionality for existing devices, like, for example, we don't support VXLAN on iOS XR because I don't have time to wait for it to boot. But if anyone wants to add VXLAN support for iOS XR, please just do it, submit the pull request, we're in business. You can add new devices if you think there is something that's still worth implementing apart from those 20 we already support. Oh, you can also implement, I don't know, IP multicast, or RIP, or Babel. Babel is available in FR routing, so we have the infrastructure. Just go and implement it. That's it. Everything is on the web. The documentation website has this cool URL that I was able to grab for only 20 euro a year. Source code is on GitHub, examples are on GitHub, integration tests are on GitHub, and you can use those to see, you know, we are currently testing like 60 or 70 different scenarios over 10 platforms, I think. And I don't have the URL for the integration test results, but there is a website where you can look at what is actually supported and working on each individual device. If you use the tool, if you encounter problems, please, you can send me an email. Obviously, I'll try to reply, but do open a GitHub issue or discussion so that everyone else can benefit from our chat. Because those things are searchable, and everyone can search them. They can't search my email yet. And that's all I had to say. Hope you'll download the tool, try it out, let me know how it works, and enjoy it. Thank you.
Do you have any questions? Thank you for a really good presentation. Yeah, the question, okay. Go to the mic. Please go to the mic, yeah.
Roman Łopacz from Poznań Supercomputing and Networking Center in Poland. Very interesting presentation. Thank you very much for that. So I want to ask one thing, because in my institution, my team, I have 2 colleagues who are playing with Container Lab. So they can create a virtual copy of the simple infrastructure, a subset of our network. So, and it works. It's not perfect, but it works. They play with it, with that a bit. So the question is, what's the difference between NetLab and Container Lab? What's the added value? Because I didn't catch it. So please.
Yeah, thanks. Great question. Container Lab orchestrates the containers. So you build a topology, how things should be connected, the links and the nodes, and then it starts the labs. And it provisions some sort of initial device configuration on every container. You can use existing configuration, and then the Container Lab will install the existing device configuration on your containers. So if you are replicating your network and you already have the device configurations, or if you have a long-term project where you're working on the same topology for, I don't know, weeks at a time, then Container Lab is just what you need. if you want to create a new lab in a reasonable time, and you want to have it pre-provisioned like 90% of the boring stuff is already done for you, then you should look at NetLab. Because NetLab does all the IP addressing for you, it does all the routing protocols for you, it does, all that stuff that I mentioned. So you get the lab that is totally fresh, but provisioned like 90% of what you want to do. So because one of the things that I was doing in my life, and I hated it, was I always tried to find some lab topology that was very close to what I wanted to test today, so that I wouldn't have to do all the boring stuff. Now I don't have to do that anymore, because now the boring stuff is done for me every time I create the new topology.
Okay. So documentation is on the GitHub.
Yes.
I understand all the examples. Okay, great. Thanks.
If anything is missing, let me know.
Yeah, for sure. Thanks.
Thank you. Any more questions, maybe? No. Thank you once again for the presentation. Next up, we have Gianluca Sironi regarding IXP traffic patterns.
Yeah, can you hear me? Hi everybody. Good afternoon. I'm Gianluca Sironi from NAQUADRIA, and you see also in the corner PCIX, which is a small internet exchange we founded some years ago, and that's one of the reasons of this project, or at least project proposal. And we start analyzing our traffic. We are a very small IX, but within the community, especially the Milan-based area community and the Italian network operators groups, we started discussing, and then say, why can't we gather, collect, create some data sets in order to analyze in a shared and a peer review all the traffic data in order to have some insights, some specific patterns to identify, also to review some issues or faults that happens and maybe are not spread throughout the thing. So let's, I hope that this is, yes. So actually, as I said, it started during the MINOG meetings. MINOG, it's the Milan-based group which holds regular meetings, actually once a month, that are, those meetings are dinners indeed, and so maybe drinking, it's easier to talk also about technical issue, and you see in the last line, it's not a competition, even if there are competitors during that dinner or those meetings are easier to talk. One of my, not only mine, but one of my goals was to analyze not the long-term trends and stay growth 20% in a year. In the last 5 years, I hit this traffic record. This is not the meaning, even if it has interesting data, but to analyze specific daily data in order to identify specific partners. For example, how traffic is in the night, or at about what hour is the lowest value, or how large is the, let's say, very low value pattern, and then what's the behavior in the morning, which is very different, and you will see from north of Europe, also north of Italy compared to the south of Italy, and it is a neutral statement. And all of this, let's say, gathering and collecting, and also all this analysis are supposed to be very low effort, at completely no cost for the XP. And if they are available to share data or have data to be shared. And so that's why we are trying to cooperate, and here is also a request for cooperation. Let's go on the other way. Yes, so something else already said. One of the goals is to analyze the, for example, the different patterns between different weekdays and weekends, especially in Italy, with evaluating, measuring the effect of the football matches. Sorry for that, but some other countries has the same the same fact. And also to define some easy data set that could be published, could be available for our people, and also together with some other, Arnold, I don't think it's here, and Annika, we are also discussing if insert this kind of data in the IX schema. Because they're supposed to be easy and should be, could be useful and work in progress. And then extract some, let's say, details and trying to measure if there is some scaling effect or at least belonging to the same country, of course, starting from Italy because the discussion started there. If there are some common effects, then you can not only compare and measure, but also some insights for a forecast, even if it is not specifically a prediction tool. We are talking at ITNOG level to settle up a working group. ITNOG meeting is 2 weeks, in 2 weeks we will hold it, and then maybe if there is some interest, we will enlarge this common, also open, of course, to foreign colleagues. Let's go straight. Okay, we run an XP, so we have our own data, but it's very small. We don't have a retail customer, so it's a business traffic. It could be like, let's say, 10 years ago, a shape, not very interesting if related to the volumes. So, dear IXs, could you give us the data, or is there any data available? The answer is half yes, half no. The lucky was that within the MINOG working group, there is Marco Ditri, which I think most of you know, which is one of the contributors of XP Manager, which is an open source software. Let's say the project is held by the Annex, the Irish colleagues. And then you show me, let's say, maybe, likely, and then that's it. There is some API you can fetch the values you want. So, okay, starting from MINAP, which is the IXP, together with Mix, based in Milan, we start gathering and collecting data. Then I see Maurizio down there, also Namex in Rome, helped us because Flavio, which is another colleague that I think you know. Also we are using SP Manager, so we have the same interface. Please use also our data and then discuss how to use, how to deal, and then we do some articles, some posts also with Flavio. And about the other internet exchanges that are not using this very simple API, let's say still waiting. We can, of course, scrub and fetch somehow from their pages every data we want, but it's very complicated because there is not a standard pattern to compare at least with the XP Manager based. Straight. So, starting from the Italian ones, so MINAP in Milan or Namex in Rome, we say, how there are a lot of XP manager-based XP. So we start collecting, starting from Ireland, of course, then in England, in Sweden, and so on, so on, so on. And about these meetings, there is an interesting number, starting from the Greek IX, which is the main IX in Greek, and also the Interline in Romania. And also, let's say in Bosnia and Herzegovina, you see all the countries, and in Croatia. So we started, let's say not in the same time, gathering this value, meanwhile trying to build, let's say, a tool or a pattern that could easily calculate the standard mathematics you want to perform, which is, sorry, a little bit back, which is supposed to be simple enough to be portable, but enough complicated to calculate some specific values that, for example, filter the outliers or identify some high-dimensional variables that could identify better the pattern, at least compared to two, but we will see later. Let's go straight. There is the link of the documentation for the XP Manager. There is a JSON file exposed. This is an example, I don't know, but this is, maybe they changed some months ago, but this was before. If you go to the documents of the XP Manager, you find that. So we do simply that. We pull the list of the IX you see, of course, with the same query, a very easy query. We get this JSON with a simple parser. We use usually JQ. Fetch or retrieve these values or the values you want. We add an UTC standard timestamp. Actually, we do also another copy with the local time. Why the local time? Because the UTC, it's universal. You can compare, use the whatever you want. But starting from analyzing Italian events, there are strictly related football matches to a specific time frame. So it's important to have also the local time. Very, very quickly, within this few data, you can do a lot of things. Very, very lot of things. We try to analyze, of course, the standard statistics, but also to push on the normalization. Why normalization? Because in order to find out if there are some correlation between days, between weeks, and then within the same IX. And then the next steps is in the same area, if the same event is affected or affecting a group of IXP, you will see an example. And then there is, I don't know if you are used to all those terms, but some normalization are very strong for regular data. If data are not so regular, it's better to use some other standards, but anyway, never mind. Talking with Arnold and so on, he say, trying to identify this scaling factor within IX could be interesting to also retrieve the number of the peers at the time. So there is no data on the XP Manager, but we are using the PeeringDB. Talking with PeeringDB guys, there is no specific JSON output for the number of peers at the time. Same, we are talking to them, maybe to have this simple data in the, if you've got the list of the members, the list of the peers, but not this simple data. So a simple query that runs every day. I took this 2 days because you can see small differences in someone and then the list of the IX we are using. What we used to do is something like this. First, analyzing a single week. Because, let's say, maybe I have a financial bias because I've been working still in a financial, in the banking industry for about 25 years. So the seasonality, if you consider this as time series, is a week. because the difference between weekdays and weekends is very strong. Not in the case of traffic, but it's a sound base because there are a lot of methods that can be used to analyze that. One of the things we measure is, of course, at what time the minimum happens. And then if there is a consistent pattern, and you see if there are at least 2 days which have different patterns, and the ratio, so the maximum of the day compared to the minimum of the weekly. As you can see, the minimum are very close, so there is not a big difference, let's say 10%, 15%, 20% at most. And you will see that, of course, gathering all this data, we see there are differences, also big differences between IX. And for example, this is in the Romanian. You see the pattern, the same week, of course. The pattern is very similar, it's more consistent. There is no so difference as you see in the evening, and also the time frame of the minimum is similar, but you see the numbers or the ratio for maximum and minimum are very different. So we are talking about, let's say, 4.5, but instead compared to 5, it's 20% at least. Straight another, this is a very easy outcome that you say, let's say the standard statistics, so the average, the minimum, the maximum, the median, which is that important because a measure of how the dispersion is for the distribution. And what is important is, at least for us, at least talking to Italy, because we don't know enough about the Greek behavior and how to measure the difference between the maximum and the 90 percentile. Because, for example, in Italy, 90 percentile, it's roughly 2.5 hours. Again, it's the time frame of a football match, and you can measure directly the impact of a football match, measuring the differences. Again, instead of having, this is quite the classic graphs that you know, but the weeks are overlapped. That's it, the first quarter, so they are 13 weeks. You can follow the weeks, that is, let's say, nice. Maybe if it's not useful, it's kind of Pollock paintings, if you don't want to use as a number, but whatever. And what you can see, it's how consistent is the pattern, even if you can see or measure, better if a table, the difference between days and within time frame in the specific days. The fact is that at least the night is very regular. The days are affected by specific effect. On that, you see the week 10, which is the small green on the Friday, so the Monday to Sunday. On the Friday, there was a strange behavior, very strange compared to the other. We found out that it was a fortnight release on that day, and you see also in other IX that effect, and that's even greater. We use usually this, we also with this without the median, but we use also the median because you can see how close they are, especially if you want to extract one specific week and then do some calculation. You will see later in a short example. Again, same time frame, first quarter. This is Romania, very similar. You see closer the ratio makes maximum minimum as we discussed together, and data are more consistent. You will see also in some statistic parameters like the coefficient variation, but never mind. Interestingly, at least to me, because I want to talk with Romanian colleagues, these nice colors, especially during the weekend, are decreasingly, let's say. The fact is that if you follow that, and an animation could be better, if you follow that in a strange way, they are, maybe it's related to spring, maybe, we don't know, but during the weekend, actually, they are decreasing. This is same for Croatia, and less, but we've seen the same phenomenon. I go straight. one of the things we used to do, or at least to identify a pattern, this is a standard week, the week 12 of the Greek IX. We used to extract, for example, this is an example for tens of gigabits of the number of occurrences, so the frequency, in order to have a count, simple count. Maybe it is better. Sorry, I very quickly go back to show you a thing. We, as you know, there is 3-5 minutes average that is discussed. We see that during the polling, quite often, it is not yet published, so we get the same value, which is not very useful. So we sample, which is, let's say, a fetching of a sample, actually, every 10 minutes. We have in this way 144 samples a day, which is not very much, and about 1,000 a week. This is an interesting number, at least, of course, you can double it, but no more than double because the average is on 5 minutes. Because it is very close to 1,024, which can be used for the fast Fourier transform, we are also working on extracting the principal components. Straight to where we were. So in this way, we can try to extract the frequency of the traffic, not related to specific time frame, but to traffic. And what it comes out is that is, let's say, this is the Greek pattern of the first order. You can isolate, for example, how deep is the minimum. You can, let's say, the number times 10 minutes. You can say how many hours you are under a certain threshold or whatever, or how large is the dispersion on top. So how they are different, the maximum within the weeks and within the months and the quarter in this case. It's very large. So, for example, this could be analyzed with a simple model, but for example, if in a software-defined optic, you can plan how to use your resourcer, or at least not in the most efficient way, but in a more efficient way. This is the same for Romania, which is closer and which is, let's say, very specific kernel, let's say, in the middle of the day and also in the middle of the interval of the gigabits used. Again, for this is for comparison Ireland, which was you remember the base of the project for the XP manager. And it's quite similar to the Greek. It's larger because even if the scale is not so different, we are talking about, let's say, the average, some hundreds of gigabits, and the maximum 1 terabyte and more. But some maximum are related to specific events. What I refer is dealing with numbers. I know they are boring, but this is, for example, if you take the whole quarter and do the correlation between weeks, you can easily find that so the number is very high. So who is used to mathematics when you have a correlation of 0.7, 0.8, the phenomena are strongly correlated. We are always more than 0.9, but we are looking for the differences. So you will see the first week was a very low traffic week, and then the first column, so the correlation between the first week and the other is very low. And then we show you that on the week 10 there was this strange fortnight update. So also the week 10, even if it is only 1 day, has an interesting impact in terms of difference to all the other. Same thing, of course, for Romania, which is concentrated in maybe the holiday, the holidays are better. Same for Croatian. And go to the let's say, how to normalize, how to compare, how to deal different IX, trying to keep the important features. This is, for example, week 8, it's an example. This is what is called the min-max normalization that is related to the minimum value of the weeks and the maximum value of the week. Let's say the formula is compared to the minimum. The range, which is the maximum and the minimum, is divided by the range, and then you have the value subtraction the minimum. So you can have all this value in a good scale, because between 0 and 1 you can deal whatever in whatever way you want. And the problem is that if there is some spike or some strange maximum or strange minimum, it's the same. This could be, let's say, there could be kind of distortion. But let's say, thinking that it could be an easy measure. For example, this way. Same week, we get the 3 of the SE IX that we are working on. Actually, we have data of all, but I'm sorry for the other, I use these 3. You compare, and then as a quick look, you can see that the Greek pattern is very different from the other one. Meanwhile, if you take a look at the orange and the gray, so Romania and Croatia, even with different values, very different values, seems to behave roughly the same. And then you can analyze, for example, what's happening on Saturday evening, Saturday night, and whatever. Again, another way to normalize data in order to clean or to smooth potential outliers, potential effects, is to use what is called the standardization, the z-score normalization, which is based on the average on the standard deviation. I don't want to bore. And again, what you can do is to use, let's say, cross IX or between IX. This is, for example, that one was week 9. I pick one, for example. And this is from 7 to 11, so you can read. And you can see that, for example, in week 11, at least on Sunday and also on Thursday night, something very special happened. But if you check, for example, Monday, it seems exactly the same day. And also Tuesday seems. So you can figure out, let's say, the difference and concentrate to the difference to correlate, if, for example, if there was a fault for a provider or whatever. And then what else? I see 2 Namex guys down there. I hope it's okay. These are your first quarter. No? And I highlighted the Wednesday. That's it, because on Wednesday, especially Wednesday night in Italy, there is the football matches and this Amazon Prime Video, which is an exclusive right to broadcast that. And the fact is that compared to the other days, it's ugly. You see that the week 10, it's very easy. If you remind the fortnight update on that Friday, is that. The interesting, a little bit sad fact about Italy is that the peak is week 11, if I remember well, was the Inter-Atletico Madrid match, and was that day the record. The previous one is the seems yellow, dark yellow one, which was another football match and was at the time the record of the IX. And it is not in this because the quarter ended. Last week there was a football match not with Italian teams, and this is the top record of the Namex, not only also the MINAP. So we are, seems a football country, but never mind. And this is the details of the Wednesday, and the evening is quite crazy. An example of evaluating the relation is related to the end of last year. It was roughly 4 months. This was at Meetup, but we have exactly the same at Namex and also INEX. There are some patterns consistent. There are the Sundays. The interesting fact that if you follow the time at 6 p.m. or in the evening are football matches. But there is some, at least the gray and the yellow, which are Christmas Eve and the last day of the year. And the very, very strange effect is about that dark green line, which is a fortnight update that happens on Sunday. It was the beginning of December. If you remember, you used to calculate, use the average or the median of the day. If you extract, I mean, these 3 outliers, or weekly outliers, and calculate the average of the rest in 4 months, this is a sound measure, and you compare to that, we see that, let's say, in the evening of, it's good, I think, of Christmas, you have roughly 50% less of traffic. Maybe people is having dinner with their families, but the astonishing, at least for me, fact that is not so far from 100%. So you see the peak on the green line compared to the normal traffic of the Sunday. So that day, it seems like a completely different IX. There are some notes down there about this, if you want to see. These are tables, I know they are boring, but I want to point just a little thing. Instead, the average. This is the average of the week, the first column. This is the Greek one. You see the numbers. There is, let's say, that you analyzed. But if we go on the Romanian, it is quite evident the one thing that I was saying, that is decreasing. And we are trying to draw it, if you see the green, the gray line, even if they are too scaled, there are the Romanian is steadily decreasing. Next steps are there. Decide how to publish, extend the X, define together with people some other metrics and so on, and hope to share knowledge. That's it. And it depends. I prefer tables, but I know that numbers are not easy to read. Even depends on how you are. But for example, this interesting pattern about the Romanian decreasing traffic during the weekend, following the weeks, are quite interesting, and I would like to talk with some Romanian colleagues. Any question? Yeah. I hope some suggestion.
Any questions? Don't be shy.
I'm shy.
Thank you, Gianluca, for the presentation.
Thank you.
Moving on, so we won't be having a break now, but we're moving on to lightning talks. So first of all, I would like to invite Livio and Morina regarding PeeringDB.
Good evening. A brief introduction. I'm Livio Morina. I'm a board member of PeeringDB, and I'm also the CEO of an internet operator and a board member of the Italian Association of ISPs. I'm here, I will be brief because I set the presentation for 1 hour, but I heard that I have 10 minutes, so I will try to keep it short, shorter than planned. Who doesn't know PeeringDB? Let's go ahead. Okay, PeeringDB was born mainly to help the interconnection of operators. So based on layer 3 in the pile of ISO OZ protocols. And now PeeringDB is a bit more than this, because in PeeringDB you can find facilities, you can find carriers and so on. So it's a place where operators are able to take decisions. So if you want to join a new market, you can start checking what is available in that market, and you can start from a large set of data that is available through the website. PeeringDB can be accessed by the website, so the standard web interface, but also through APIs. APIs are very useful when you start to work with PeeringDB doing automation. We encourage the automation, and we encourage you to submit new suggestions. For example, if Gianluca needs a record or an API that we don't have, we have a GitHub where everyone can submit the proposal. And our developer team take the decision, or our product team take the decision based on the consensus. So if we here decide to make a function on PeeringDB and we all submit the thumb up, PeeringDB will do that. But we will take an evaluation to understand if it will break something else. So we are not going straight on the suggestions. I want to spend a couple of minutes on the governance, because in this moment there is an active election open. So you can vote for the board. We have 2 seats available, and let me see. Oh, this is the board today, and we have 2 seats. Every member can cast a vote. A member doesn't mean that you are registered on PeeringDB. To be member, you have to be. Let me see. Well, this is the poll. They are random. The name are randomized, and this is the difference between user when you are registered on the PeeringDB and members. The members are one guy that is the referral for one organization. And in that case, he can cast 1 vote. If there is an organization that owns another organization, the vote is just 1. So keep updated your RIPE records or any other records on other area, because when you try to subscribe to the PeeringDB Gov mailing list, that is the mailing list related to the government of the association, with a very few mails. I think in 2023, the mails were about 25, 26, so a very few emails. And in that case, you can also register now, because the elections will end on the 29th, if I'm not wrong. And so you can just be a member and participate to the decision. In PeeringDB, we have around, I have to check the next slide, but I start from now to guess the number, around 28,000 registered networks. The votes that can be casted are only 480. So only 480 organizations has the opportunity to cast a vote. And if we check the previous elections, I think we are around 100 really casted votes. So we need the participation of the community, because PeeringDB is a voluntary-based association. And without you, we cannot go ahead, you and me. Here is the workflow of the project. As I told you, on GitHub, you can submit your suggestion. You can say, this is not working, this is working, I want to do this, how can we do that? You can go ahead with GitHub, and then we will take decision about that. We have a beta program where I encourage you to participate. You just have to do beta.peeringdb.com, where you can test the new functions, because it happened last month that we had to do a rollback of the whole new GUI we introduced, because it was not working well. But the beta website is accessed only by 0.5% of the users. So it is not so easy to spot the problems in advance. So if you can use the beta website as base interface. We had problems up to last month, because the beta website used to update once a month. So you have outdated the data there, so you cannot take the right decisions. But now we update the beta website once every hour. So you always have barely close live results. beta server on that page, last changes. Oh, we are developing the new user interface. We are working on that, and we hope that it will be better than the last try we made. We acquired the suggestions we received. We have also I don't know, one step back. We have the KMZ exportation on the website, on the bottom of the website. Every day it gets updated. So you can download the whole facilities in one single KMZ and take the decisions. Now we are implementing a better way to export the data contained in the file, but we are improving also this part, acquiring your suggestions. The search is getting improved too. This version, we are now on a beta that will be definitive on Tuesday or Wednesday, and there is a new web search engine behind that, and we will release a new one, an improved one, next month. Also, the website, as you see, will have a column to be faster, to make the searches or to jump from a section to another. The loading will be also faster. This is what I said about the KMZ. You can export it and import in the Google Earth, sorry. This is the searching engine we are working on, because if you try to fill the search engine with a location, we used to add a huge number of results that were not related to the location, and maybe you were missing the ones that are real in that location. Yes, it is a matter of work on that, and we are doing our best to reach the best situation. As I said, we need beta testers, so if you want to test the beta releases, you're welcome. You can submit your feedbacks. We have our team that is doing the tests, but probably we are doing all the same things. So if you do what you used to do on PeeringDB with your ideas, with your head, maybe we will spot something more. We are voluntary based, so we are also looking for volunteers. Volunteers mainly for the admin committee. Admin committee is the committee that is managing the tickets. All the requests you send are managed by the admin committee. We calculated that the need is at least 1 hour a week. So if you can plan an exclusive hour to dedicate that hour at PeeringDB, you can send us an email to the admin committee, and I'm pretty sure that you will be welcome. This is a tracking of the growth of PeeringDB. As you can see, from year to year, we had a nice and cool number of new objects. We have the 10% average of increase. That's a great result, but we are still missing a lot of data, mainly from some country. In India, we are missing a lot of data, and also in other countries. We are working on that area. So next week, we will be also in Sanog, in Bombay, for the presentation in that area, and we are trying to acquiring that data. These are our sponsors, because as I told you, we are not paid by a company, a government, or any other entity. We are just founding us with our sponsors. So without sponsor, we cannot go ahead. If you want to be a sponsor, you can ping me. No, I'm here. And what can I say? Do you have any question about what I said? If you want help to become a member, just ping me. We can take a look together and see what is the need for to be a member. Yes.
Hi. I have a question. I'm from Turkey. I had a bit of knowledge back in 2020 how the big ISPs peer with themselves, with each other. So is it necessary for big ISPs that do private peering, so they're not present on the IXPs, is it necessary for them to publish this information to PeeringDB?
Necessary, maybe, because if you are an operator and you want to decide where to go to get, for example, the Google cache, you can check PeeringDB and see where Google is located, but you could have no PNI in that data center. So you have to send an email, by the way, to the Google or any other company to know exactly if you can do the PNI there, because the PNI places, if we want, we call that in this way, they are not available. So you can understand where an operator is active, but not what is doing there. You can know something, because there are the objects that are the carrier objects. That means that that operator will be able to carry you from one data center to another data center, but the PNI object doesn't exist. If it makes sense, you can open a GitHub request and we can discuss about that. That maybe it is very interesting because the PNIs are maybe the future of the interconnections.
Thank you.
Any more questions?
Thank you.
Thank you. Thank you, Livio. Next up, Silvio Oertli, talking about 30 years of security collaboration in Europe.
So yeah, thank you. Hello, everyone. I like to hook in where the panel this afternoon stopped. But first, my name is Silvio. I'm working for SWITCH, the Swiss National Research and Education Network, as a security engineer for about almost 9 years now. And I'm also the chair of the Task Force CSIRT. Now, the question, who of you ever heard about Task Force CSIRT? Some of you, okay. The purpose of the Task Force CSIRT is to together give more resilience on the internet, on the Europe. So you have heard the European Academic Network started in 1984, and a lot of these network teams quickly started to have security teams if there is an incident to help them. And so it happens that in 1993, on behalf of the initiative of the German and the Dutch guys, the first meeting of such security teams happens in Europe. So a little bit more than 30 years ago. And the idea then was to create one CERT for whole Europe, and that failed. And then they said, okay, perhaps it's not good that we have one CERT that serves the same services all over the place, because we have different needs in different countries, but we can collaborate and share experience, share knowledge on that. And so how the whole Task Force CSIRT started, first under the umbrella of Terena, then Géant, and since 2022 we have seen that we are not just the academic network people or security people. We have a lot of other sectors in there, governmental certs, national CSIRTs. We have P-certs, ISOC are coming, SOCs are coming, and then we say, okay, and even private CSIRTs. So to fulfill all the needs we have to go under an own umbrella. So we founded a foundation under Dutch law. What can you get if you are a security teams participating in this foundation? We have the trusted introducer services, which gives you a database with all the information if you need someone to connect to. We have a secure mailing list with PGP encryption. We have a wiki, we have chat, all the stuff you get. And one thing could be of interest if you have your own AS number and RIPE entry, even if not very common, but you can give the maintenance of your IRT object to them and they will do it for you. And then to strong the community, we have 3 pillars. The first one is meeting. We meet each other 3 times a year. The goal is that we do everything what we do make affordable as possible. So the meetings are in general for free. There is one of the 3 meeting together with First, and there we have to charge a little bit, but the other 2 are free for every team members, as well from people outside. We developed trainings together that we say, okay, we have new people in the field and train them on organization, operational, on technical level, what are the threats out there in the internet, as well as some legal stuff, what have you to consider if you do your daily work. And the last one is, apparently 10, 15 years ago, the community sat together and said, okay, let's do some kind of a framework, that's the THIM3 framework, how we can measure the maturity of a team. Not to show all other ones how mature you are, more to have an external audit on you which gives you some hints where you can improve. And with these 3, we think we can build a stronger community together. As I mentioned, I like to go into the governance because the foundation was the model that we say we can keep everything out from the teams. So almost every position you see with the C that are elected from the community, and all these positions are volunteer work, so you don't get money for that, because we think we can use the money better-wise to serve back to the community. So even the steering committee, everyone is volunteered and elected, even the board of commissioners, so the supervisory board of the foundation. 3 of them are ex officio, so we have RIPE NCC as a partner in the foundation and gets a seat in the supervisory board. We have Sheon as well, and 1 person out from the THIM3 audit service, who was one of the founding fathers of the PCIX Foundation. And what you can get if you join as a team, or if you have a team that joins, so getting listing is for free, so that means you can you have access to the meeting, you have access to the database, you have access to the chat, so to be in the community, that's for free. To get listed, you need 2 accredited teams, member teams, they support you. And every 3 years you will go to the relisting process again. It's just that we can make sure that your contact data are appropriate and we can reach you at any time. Then we have 2 member levels. One is the accredited one, where you get full access and you're a full member. And the certified one is what I mean, you get certified against this THIM3 framework, which has to be done every 3 years. Gives you a value in kind of where can you improve yourself. Yeah. At the moment we have almost 300 full members, so 300 CSIRT teams in Europe and beyond are a member of TF-CSIRT. 52 of them, so even a 6th, are certified teams. And we have additional 200 listed teams. We are just joining the community. Yeah, that's it. If you have any question to that, or if you are a team, a PCIRT, a SOC, a CSIRT within your, or even if you are a member that are interested to be an associate, even that's possible. But then you need at minimum 5 teams that support you. They say that you can bring value to the community and you're in. Thank you.
Thank you.
Any questions? Yep. Or even if you have a personal one, catch me somewhere around next day.
Thank you, Silvio. Next up, the last talk of the day, Dmytro will talk about DNSSEC.
Thanks. Hi everyone, so I'll try not to delay you so you can make yourself ready for this dinner. I don't know where's my clicker, or there it is, okay. Fine, so I'm working for the Ukrainian top-level domain registry. We are being around for a lot of time, over 20 years. And it's a presentation I did before, but I adapted it for the smaller screen, I mean, for the shorter time frame. We've been running DNSSEC and DNS for a while. We use our own systems and open source software, and it's a brief history. We started it in 2011, and there were some changes. And the last big change was in 2019 when we changed the algorithm. I think it was one of the first TLDs in Europe to do that. Maybe you can raise your hand or not. If you run DNSSEC authoritative, doesn't matter, is it a big zone or your corporate zone or your hobby zone? Yeah, I see you. Thanks. It's fine. I mean, there's a lot of terminology here. I'm not going to explain it to you, but there is, let's say, DNSSEC has some feature creep. And there is some things we wanted to change. So back in the day, I wrote some shell, Perl, makefile craft to make things work. You basically rotate the private key, and then the public key is rotated with it, and then you change this so that signatures overlap or not. Why overlapping is important? You always want to publish the DNS data that is signed. You may publish the data that is double signed, but the approach we used was to double sign things periodically every month, and we wanted to change that so be more efficient. And we evaluated several solutions. We chose Not Server, which can do schedule, which you choose by number of days or hours, weeks, and it can achieve what I call zero overlap. So you never double the DNS responses, and then you can make very small incremental updates, meaning that every time you change a zone, and we run Anycast with 14 nodes, and we use several other Anycasts, including NetNode, Sysinic, 6Connect, and others, which are also consisting of multiple machines. So basically, every time I change the zone, I was pushing this update to, let's say, 100 machines worldwide, which is very suboptimal. I know it's only 10 megabyte or something, but still, you know, a lot of data traffic, some timeouts, some things. We have been partnering with Sysinic on other projects, and I got access to their team with Slack. It was very nice. Here is not what I say a timeline, it's just a few moments of time, just to give an idea how long it took us. We started in September planning this, even though evaluation started some time ago. We had done preliminary work in about a month and a half, and then we did the actual migration with under a month timeline. It was done in stages. Like any other software, there's things you can do, and sometimes you run into the combination of bad luck, bad options, bad night's sleep, and we had learned some things that are not working, which I'm going to talk about in a minute. One approach that I would say is very important for you to doing any critical infrastructure or even your own infrastructure is to never change the systems which are stable, as long as you can afford to build a new replica or half replica of something new. Somebody told me they call it red-blue team, although this is term overloaded by security people. I will call it, AB, not AB testing, but AB deployment. When you deploy something new, and then you can switch back, have a transaction where you can say, imagine you have a pipeline of A, B, and C. You can change the A system, B system, and C system. In our case, it was more like we insert the B between A and C. If the B doesn't work, we can switch back to the A to C transition. We created a new instance. The node server was running on a new virtual machine. It was all configured with a replica of data and replica of keys, and then we tried to see what happens, meaning that we basically created the parallel process that replaced the current process. It was not a lab testing, although we had some preparation done. We found some things that are basically making things not broken, but close to that. And again, if you're not running Node, this is pretty meaningless to you, but the point is that you look at these things and they don't tell you anything. And the code was just not tested, I guess, and somebody in the development team found that, and they just fixed that later. So if you install the node server today, you would not run into the issues. Basically, you can never test for anything, being a developer or a user, so don't expect things to be smoothly. So again, I would reiterate that it's always good to have a way to revert to the stable configuration, and also, of course, to use a change control system. We use Git. Well, we use GitLab instance to be exact, and be able to, to test, see the changes, roll them back, and do other things. So here are some notes. Again, if you're a DNS user, you may understand these things, but I just quickly mentioned that you can change database that the DNS server keeps by its own command set. So you don't have to edit the files. You can do transactions, meaning that you stop the server. Well, you make a database read-only, let's say, and then you change the things, and then you change them back to running. Well, some things that are mentioned here is that you can notice differences between the bind and the not, and I would say some of these differences are good, like the key database is more readable, and also notice that some of the data migration from bind was not perfect, like the key lifetime was not imported correctly. Again, this is due to the architectural decisions of the team. You may notice one more thing that is, again, maybe more interesting to the DNS geeks. You don't use double signatures with not DNS with the DNS key record. That is the record that signs the entire record set. So it's like, say, signature of signatures, and then that is, I guess, optimization of the protocol. So I'll make a few points here that is very important when you have production changes to, well, ideally know the code you use or know people who know the code and fix things that happen, and don't be afraid to make mistakes, because it's more important to have a backup plan and a way to go forward or reverse than to build a perfect execution. And if you're in the field long enough, you know that you would never have the perfect deployment every time. So I guess that's pretty much it for me. I'll be clicking to my, to my contact slide. Sure. So you can reach out to me by email, or also you can find me today or tomorrow. And yeah, I think that's it. If you need my contact details beside that, you can also find me on LinkedIn, or I can give you my phone number for WhatsApp or other messenger if you so prefer. Although email works. Thank you. I'll pass the mic.
Are there any questions for Dmytro?
Yeah. Okay. Yeah, I'm good. Are we? Yeah. Well, we are 10 minutes early, I guess.
So we can talk. Like
it's not
10
bad.
minutes.
It's all right, guys. If you want to ask me something, don't be shy and come later.
Okay, I think we're done with the sessions for today. Thank you all for joining, and hope we'll see you all at the dinner later tonight. Thank you.